Welcome to this detailed Pandas tutorial. If you want to master data manipulation and analysis in Python, you're in the right place. This video will walk you through the core concepts of Pandas with practical examples and interactive quizzes to solidify your understanding of the library. Whether you're new to Pandas or just refreshing your skills, this tutorial has something for everyone. Here's what you'll learn: how to create and work with Pandas series and DataFrames, ways to access and explore data using methods such as the iLoc and the Loc Indexers, perform key data operations such as arithmetic operations, statistical operations, sorting, and others, filter and manipulate data using conditional logic, and test your progress with quizzes throughout the session on all of these topics. By the end of this video, you will be confident in using Pandas for any data analysis challenge. If you are new here, don't forget to subscribe and click the bell icon to stay updated with our latest tech tutorials. Let's dive right in. Let's begin. Where was I? Yeah. So Pandas, right? This library called Pandas, the name is derived from panel data. And if you remember in the NumPy sessions, we spoke about two-dimensional arrays, three-dimensional arrays, things like that. Panel data is essentially mostly two-dimensional arrays, okay, where we spoke about rows and columns and things like that. So Pandas is actually open source Python. The whole of Python is open source, in fact, right? And Pandas, which is built on NumPy, by the way. So it's an open source data analysis and manipulation library for Python, which is built on top of NumPy. Okay. So in other words, when you import Pandas, it actually imports NumPy automatically in the backend. Okay. So it's completely built on top of NumPy. And here the most important thing is the two data structures that we'll be studying. One is Pandas series and the other one is Pandas DataFrame. Okay, so series is essentially one feature. So it's like, you know, production values or temperature values or revenue values, something. So it's one feature. Data frames will have multiple such features. Okay, it's actually two-dimensional object data frame. So the one thing I should mention here is that most of the methods and operations which are applied on series is also applied on data frame. The reason for this is that Pandas data frame is nothing but collection of Pandas series. We will see this when we go to data frame, but because the methods are so similar and the application is so similar, we will spend only some time investigating Pandas series. Okay, and the rest of the experimentation with series, it is left to the audience, right? But we will study Pandas data frame in detail. Okay, and as I said, most of the methods are similar between the two. So once you understand data frame, and when I show you what's happening in data frame, you'll understand even better. Then you will easily be able to connect all these methods with series methods. Having said that, we will still spend some time doing Pandas series. All right. So again, the expectation is that you run the code along with me so that we are on the same page. Okay, so that we know everything's working out and we are learning together, right? That's the expectation. So let's import Pandas, and typically when you import Pandas, the name used is PD. Okay. So first we'll talk about Pandas series. Pandas series is essentially a 1D labeled array capable of holding data of any type. Basically, it's a super array. Okay. Now, if you remember the arrays from the NumPy classes, we'll compare that with the series here. All right. All right. So first, creating series, and I just put this here on purpose so that we get this warning. As you can see, right, it's giving me some warning. It's saying, the default data type for empty series will be object instead of float. Specify a data type to silence this warning. So these kinds of warnings and updates and those kinds of things, right? This is very common in Python because it's an open source language, right? All the libraries also open source. So development keeps happening, right? So don't be surprised if you're getting any of these warnings. No problem. Sometimes you may even get an error. No problem. We just need to find out, okay, what did they change, right? What was the change in the package update or the code update, right? So what you need to do is you need to read it, right? What does it say? It says default data type will be object instead of float, and that obviously object is better. specify a data type to silence the warning. Okay, this is very common. So what did I do? Now I'll specify data type. Okay, so the command I'm using is pd.series. Note that it's a capital S. Okay, so here empty series equal to pd series, data equal to, I'm saying none, data type equal to int. Okay, I run this. Now if I just print this empty series, what does it say? It says it's a blank series with data type int32. Now if I check the type of this object, it says pandas.core series.series. Okay, so this is actually the class, right? This is the class, and the method to initiate this an object of this class is pd.series. All right, you can also print it using the print command, and it will give you the same result. So basically there is this data, and then there's the data type. This much we know. Okay, this much we know from NumPy arrays, that we need to specify some data, we need to specify a data type. Now in NumPy array you can specify data type, it automatically selects best data type also if you don't specify. Now this is where the power of the Pandas series starts becoming obvious. Okay, so suppose I have a list which has kind of some production data. So you can think of this as 1000 units produced by a factory in day 1, 1200 units produced by the factory in day 2, and so on, right? 1100 units produced in day 3. Now if you see here, I have one list which stores the production values. I have another list which tells me the day number. Notice that these are strings, these are integers. Okay, now I have these two lists. What I'm going to do is I'm going to pass the actual values, the production data values, into the data parameter here for series. Let me pass in the days, day 1, day 2, day 3, the string information, the string list, right, in the index parameter. Okay, so here I'm passing production day, and I'm giving a name to the series, right? So there's another optional parameter where you can actually give a name to the series. The name is stored along with the series, right? So this is the name of the variable. So here I'm saying daily underscore production. This is the name of the variable. This would be the name of the series. And this is optional, by the way. So anyway, let me run this. So now the series has been created. You can take a look at it. This is what a typical series is going to look like. Notice that it is different from an array, right? So series is actually a one-dimensional array, but it has labeled indices, not just integer indices. Okay, remember NumPy 1D, 2D, 3D, whatever, these NumPy arrays do not have anything other than integer indices, right? That is how we were indexing 0, 1, 2, 0, 1, 2, 0, 1, 2, correct? So now Pandas series, what it has is it has labeled indices. Okay, that doesn't mean that it does not have integer indices. It has. By default, the position of 1000 is 0, position of 1200 is 1, position of 1100 is 2, and so on. So it has the integer indices. On top of that, it also has labeled indices. Okay, now if you quickly look at the documentation of this thing, data none, index done, dtype name. Okay, so these are the main things, and you can read this more detail when you want to, but these are the things that typically that one would pass. So now I have this nice labeled map between the object day number 1 and, for example, the amount of units produced on day number 1, which is 1000. Okay, so giving a name is optional, but this is more useful when we study data frames. Okay, we'll see that. And as you can see here, I have not given the name in the second command here. I did not give the name. And this thing here, it says name is production details. So as you can see, this name thing, this name attribute is part of the object. Okay. And here there's no name, right? So for example, if you want to see the attribute, then you just do this, right? Dot name. Okay. Let me check. Okay, this thing doesn't have name right now. Yeah, I need to run this again. Then only I will get name. So now if I do daily production dot name, here you will get see name of the object, which is daily production. So notice that this is the variable name and this is the name of the series. It's as I said, it's optional. It will become more important when we do data frames. Anyway, so let me run these two cells again. Now What else, right? Now, one thing you need to notice is that it's built on top of NumPy, right? So any mismatch in the shape is going to cause a problem. So here, see, I'm taking production data from 1 to end. 1 to end means what? We know this by now, right? So if I say 1 to end, that means this much, right? 6 items, except the 0th item. Okay. So if I pass that as my data, and if I pass the full index, production day is 7 items here, right? So if I pass that as my index, then obviously there's going to be a problem. And by the way, if you retain the correct order of the parameters, then you don't need to specify the parameter name each time, like data index, right? So that I have not used here. So if I run this, it's obviously going to give me error. It says length of value 6 does not match length of index 7. Clearly the index and the data must have same length. So there is one thing you can do is either fix the index properly or you don't even specify it. So actually the index is also optional. Why is the index optional? Because on the back end, integer indices still exist, correct? So if I just declare a new Pandas series with the production data, you see the integer indices 0, 1, 2, 3, 4, 5, 6. Okay, so this is what I mean when I say that Pandas is built on top of NumPy, right? It has all the functionality of NumPy plus more, right? So if you don't specify the index, no problem, integer index, right? And if you don't have any data, then there's no point of having the series. So the main thing is the data. Anyway, so let me redeclare my daily production variable. This time I'll put the data, I'll put the index. Okay, so now I have day 1 1000 units, day 2 1200 units, and so on. And of course this is a Panda series. Now many attributes here, right? And we'll go in more detail for data frames, but as I said, there is a name attribute. Right now if you just run this, you will not get any output. Why? Because we didn't specify any name actually, right? So here if you specify a name and then you declare the variable, right? Then if you do daily production dot name, you will get the name. Right now there is 0 output. The cell is running, but there is 0 output, which means there is no name. If I just do daily production dot index, it gives me the index. If I do daily production dot values, it gives me the values. Okay. And of course you can even check the data type. So daily production dot data type, if you do, it says int64. And as I said, all of this is built on top of NumPy, which means all of this should work. Shape and dim, all of these things should work. So what is daily production dot shape? It is an array of one-dimensional array with 7 elements. And what is this daily production, guys? What is this variable? This is actually the series, right? So on the back end, it's an array, right? I hope now this whole connection is becoming clear. So NumPy is the mathematical foundation. On top of that, Pandas is the connection to data science and data analysis. Okay. And dim also will work. What is the dimensionality of the series? Obviously 1. It has only 1 dimension. What is this? You can even pull out the length using this size command. Okay, it has a size. I think NumPy arrays also have a size. Maybe we didn't explore it, but you guys can check it out later. Okay, I believe it should have a size. Maybe I may be wrong, but yeah, check it out. Then you can even use length, right? If it's a one-dimensional object, you can use len, and len is a Python method, right? It's a basic Python method. So this also gives you 7. So notice, if you want to understand your series and in terms of its attributes, you can use these commands to do that. Shape and dimension, data type, values, index, right? Everything is here. And there's also one quick way to check whether your series is empty or not. So if I just do daily production dot empty, this is what we call a flag in programming. It's called flag. Okay, flag. So this flag is false, which means that my daily production series is not empty. Okay, so if it was empty, you will get true. Fine. Great. So another way of defining series, for example, is to use dictionaries. So here in the previous case, if you saw, we used 2 lists. Okay, we used 2 lists, and this list we used for values, that is data, and then this list we used for the index, right? Very nicely we can connect this with dictionaries. Okay, so suppose I have a data like this, which is monthly expenses. It's a dictionary. As you can see, it's a dictionary. I have the keys January, February, March, April, May, and I have the values 2567, 2809, 3001. These could be in like rupees or dollars or whatever, right? So I've stored my data in dictionary, correct? Dictionary is a basic Python data structure. Again, why should we convert this to series? To do data analysis, right? That's why we're doing basic Python data structures such as list, dictionary, and so on. They are built for general purpose. So now we use those generic things and use more specific libraries like NumPy Pandas to convert them into objects which allow us to do quick data analysis. So you can directly use this dictionary, and very interesting, right? If this is one object, this dictionary is one object. That object I am passing as data. Okay, this one object I will pass as data into pd.series. Okay, now let me print the series. Notice how the index and the values are meaningfully interpreted from the keys and the values of the dictionary. So all your keys of the dictionary goes to the index, and all your values from the dictionary goes to the values. Very interesting, right? Very clean connection between dictionary and series. Okay. And for example, here what I've done, see here I have made a string input for February, and here if you see the data type is float, right? So here for this series the data type is float because all of these values are floating values. Let me use the same thing again, but instead of this 2809 floating value I will put it in quotes, so which is a string right now. Interestingly enough, what happens is the series still allows to be built without any warning or error. Right now it looks like these are still floating values, but notice that the data type of the series has changed to object. So then you might be thinking, all of these things also, did the data type get converted to object? That's what happened in NumPy arrays. When you mixed string and integer and whatever into the same array, then the array automatically takes the best data type to incorporate all the data and converts. Series is actually better than that, right? So for example, if I take the January element, so accessing we will do in more detail, but the way to access is just expenses series, name of the series, and then bracket, and then give the key value, that is Jan, right? So if I take out the Jan, it says float. Type of the Jan element is float. And if I take out February, which is supposed to be float, right? If you remember, this was a floating value, right? 2567, this is a floating value, which means it's a number. Okay. And type of February we specified here as string. So if I print this, it says string. So notice how the series shows object data type. Okay. But all the elements within the series still have their own data type and it is retained. Notice how powerful this is. So this doesn't mean that you should just have January, February, March, April, day 1, day 2, day 3, and then you have same kind of value like revenue, or profit. No, you can actually have mixed information. You can have name of employee, salary of employee, right? Position of employee, location of employee, various data types you can have in the same series, right? So hope we are starting to see why this is important for data handling and data analysis, right? Very powerful object. Okay, so what we did was we looked at some important attributes of series. Okay, you are definitely encouraged to explore series further, but primarily we'll be spending a lot of time on data frames, right? Okay, example 2, some series operations. As I said, we will look at a few operations, okay, but all of these we will look in more detail when we do data frame. So again, I'm going to use daily production. So again, day 1, day 2, day 3, day 4, 1000 units, 1200 units, so on. And what is the name here? Well, it has no name, right? So one interesting method to rename this thing, you can actually rename the series, right? So here if you say daily production dot rename, and then you just give the name. So see, sometimes I'm showing the parameters here, but most methods in Python are designed such that even if you forget the parameter name, it will work. That's how they design the libraries. They make it human friendly. Okay, but still I'm showing the parameter name. So rename and then index equal to, so suppose I want to give the name daily underscore prod. Okay, so now if you see here it says name is daily underscore prod. Okay, this is one way to rename. right? But if you see here, this is the funny thing, right? If you print this again, where is the name? It is not there because this is not in place operation, right? We spoke about this in place operations, right? You remember? So if you want to make changes directly to your object, most pandas methods give you this parameter option in place. Okay, this will become very important when you work with a lot of data. So same method, daily production dot rename. Okay, and I'm giving the new name. This time I'm saying in place equal to true. Now, if you check the documentation, okay, I'm not opening it here, but if you check the documentation, the default value of in place is false. Okay, why? Because safety. By mistake, what if I change the original data, right? So default is false. So the user has to specifically say in place equal to true. Okay, so now if I say that, of course, the output is the same as previous, right? This output and this output are exactly the same, but my name has now been updated. Okay, so this is to sort of show that, look, in place operations are everywhere in pandas. What most of what you do will not be in place. Okay, similar to NumPy, and this time they actually gave us a proper parameter to control that. Another way to there are and another point is this is not the only way to make changes, right? You can make changes like this also. Very interesting. So this is temporary, right? This command here, whatever I highlighted, that is the same thing which is here. Okay, so I did not put in place equal to true here, right? Which is why your name did not get updated. But it gives me a temporary output, isn't it? This not in place operation gives me a temporary output. That temporary output I can assign to my original data, and that will replace the original data. So suppose here the name I want to give is prod daily, and I assign this whole output, right, of the temporary output of the operation to the object, right? And then I check daily production name. It is now updated properly. That is another way of making changes. There is still other way of making changes, which is directly changing the attribute. So right now, daily production dot name, this attribute of this object, daily production, is prod underscore daily. You can directly change the attribute of the object. So here, daily production underscore name, I'm giving a new name, which is daily underscore production. Okay, so this I'm using to change the attribute itself. Now if I print the updated attribute, as you can see, the name has been updated. So the point I'm trying to make here is, see, Pandas offers multiple ways to achieve the same effect in many of its methods. Okay, you can directly change the attribute, you can assign the temporary output to the original variable, or you can set in place equal to true. Typically, what we do typically is we try to use the in place parameter wherever we want to change the original object. We will control this parameter typically, but you can use the other methods also, no issues. Okay. And one small thing to notice here is that the very interesting part is that the index of the series has a name and the series can have a different name. Okay, so this is not very important. It's just for people who are interested a little bit more in all these things. You can check these methods. Okay. Now, for example, right now daily production, you see these are the index, right? Day 1, day 2, day 3, day 4, day 6, day 7. There is a method called reset index. So object dot reset index. If I do this, very interesting. What you're looking at here is called the data frame. Okay, we will study this in greater detail a bit later in the session, but this is what a data frame looks like. So look here, this is what a series looks like. Okay, it gives you the index, values, data type, and optionally name. Now this reset index method, what it did was it basically forced my index to become integer. So my previous index was day 1, day 2, day 3, day 4, right? It kicked out that index and stored it as a separate column, and it forced the actual index to become integer. Now if you check the type of this object, so I'll just take this command because it's a temporary output, right? It's not in place operation. So if I copy this whole thing and then again I execute the command and this time I check type, here you will see it says pandas.core.frame data frame. Okay, so this is the thing that we'll be working with a lot. Anyway, so now obviously these are not in place operations again, right? These are not in place operations. So if I print daily production again here, I will get my series, because all of this is like, temporary outputs, not in place. Okay, so currently my index is day 1, day 2, day 3, day 4, whatever. So the same reset index method, if I say drop equal to true, there is a parameter called drop, and I think we can all understand what it's for. It's choosing whether to keep the old index or drop the old index. Okay, so previously I did not specify, right, the drop parameter, which obviously by default is false, which is why the old index has been retained. I can choose to drop it. So if I now drop, as you can see, the old index is gone, and you can only see the integer index now, 0, 1, 2, 3, 4, 5, 6. Again, this is obviously not in place. Okay, now if you check the type, and it should be obvious, this by now we know what a series looks like and what a data frame looks like. This is a data frame, this is a series. So if you check the type of this, it will say Pandas core series. Okay, and another thing very obvious, that none of these operations is in place. So my original daily production object is still intact. It's still the way it is, day 1, day 2, day 3, day 4, 1200, whatever, right? And the index is day 1, day 2, day 6, right? So if you want to reset index and you want in place, then you have to choose the correct combination of parameters. So if I say drop equal to true and in place equal to true, and then print the index, now you see the index is a range. Okay, it's not day 1, day 2, day 3 anymore, it's a range index. Okay, and if you print the daily production object at this stage, you can see that it has changed. The object has changed. Now, as I said, there are multiple ways to change things in Pandas. In place is one way. I said another way is assigning. So now if I want to assign a new index, what I can do is I can use a list, right? So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, instead of day 1, day 2, day 3, right? So this list I can assign to the attribute itself, right? So daily production, the Pandas series object, has an attribute called index. So I can change that attribute directly. So here I am assigning this list to this attribute. Currently, what is the attribute or index? 0, 1, 2, 3, 4, 5, 6. That you can see here. Range index, start 0, stop 7, step 1. Okay. So currently this is it, 0, 1, 2, 3, 4, 5, 6. Now I can just assign this and see what happens. As you can see, the new values are updated in the actual variable. Okay. All right. Typically, see, Pandas library, as I told you, calls NumPy by default in the backend, but we can import it explicitly if we want, which is typically the general practice. Now, in this notebook and maybe tomorrow's session, we may not be using NumPy more directly, right? But more or less, when you do more advanced analysis, these two things will always be imported. Import NumPy as NP, import Pandas as PD. These two will almost always be imported together. Okay. So for now, let's just import them to show some things. Basically, I want to show that it's not just lists that you can use for data and index. You can use arrays also, right? So in Python, we call this list-like or array-like objects, right? So many of these packages allow for multiple similar behavior data structures. So when I define the values and the index for the Pandas series earlier, I use lists. The dictionary one is separate, that is another method. But if you want to do it separately, I specified lists. That doesn't mean I cannot use arrays. I can use arrays. Okay. So suppose if I have now employee names Arti, David, Mahmood, and Pranjal. This is an array, and I have employee IDs 7634 something something. These are also arrays. So these two are actually NumPy arrays now. You can use these as data and index also, right? Any list like object, any array like object can be used. So notice that the index comes second and the name comes first. Okay, that is something you guys need to remember. The first parameter is the data, the second parameter is the index. So index, what happened? My employee ID went to index and name is my value. Okay, and as I said, you can specify this without any index also, no problem. And if you just pass the array, you will get integer indices. Okay, on which day did my factory produce more than 1000 units? Answer should be Tuesday, Saturday, Sunday, right? So if I just do this, what will you get? False, true, true, false, true, 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 whatever, right? This is exactly like what is that, NumPy, isn't it? Exactly like NumPy. And notice that the output is also a series, right? This output, this logical output, is a series, and the name of the series is still the same, daily production, and data type is Boolean. So when you apply logical operator like this on a series, it will output a series. That is the powerful part, correct? So now I can use this to subset this. Okay, so wherever true is there, it will give me that value. So if I say daily production index with daily production greater than 1000, you will get the subset of the series where the production was more than 1000 units. Very simple. Tuesday, Wednesday, Friday, Saturday, Sunday. Similarly, you can do multiple. So if I have greater than 1000, I have these false, false, true, true, whatever. Less than 1500, I have true, 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 false, whatever, right? Now, if you want to do both of these, you just need to combine the logic, right? You just need to do AND operation between these two if you want both, right? And we've already seen this doesn't work because of ambiguity. So if you do this, it's ambiguous because there's no brackets, right? Which operation to do first. So there's a problem here with ambiguity. Typically, the way to solve is to put your logical operations inside parentheses, brackets, and then you can use AND. So when you do this and this, wherever both are true, only that will be true, which means both conditions need to be satisfied. So both of these conditions, if you satisfy, what is this, 1000 and 1500, right? So if you go here, this should come, this should come, this should come, this should come, right? Tuesday, Wednesday, Friday, Saturday. These four should come. Those are between 1000 and 1500. So now you can use this full logical condition, right? Put it inside indexer, right? Use this for indexing, and then print from daily production. You will get Tuesday, Wednesday, Friday, Saturday. So logical operations, same as NumPy. Okay. Other operations also same as NumPy, max, min, all of these things, right? So if you do daily production dot max, out of daily production, let me just print it again, daily production. Out of these, which is the maximum value? Obviously Sunday, 1760. So daily production dot max gives you 1760. The interesting thing about Pandas is there's a nice method IDX max, index max, by the way. That's what this method is. It gives you the index where the value is maximum. So now if I ask the question, on which day did my factory produce the maximum number of units? Sunday. Okay, so this function IDX max gives you the index where the maximum value is there. Similarly, you can have min. So daily production dot min, if you do, you'll get 950, right? And again, you can use IDX min. This is giving you the index of the minimum value. So when did my factory produce the least units in this week? Thursday. So now I can go ask the question, why Thursday, why Sunday, right? This is the beginning of analyzing data, right? So some other methods like sort values, these are very important in Pandas. In NumPy, typically sorting we did not look at because it's more of a mathematical structure named NumPy array where I don't want to mess around with my data so much, right? But in Pandas, it's perfectly normal. It's expected, right? When you do data analysis, it's expected to do sorting and all of those things. So there's a method called sort values, which sorts the series according to values. Okay, and remember that the output is series. Each time when you apply this function, and these are all built-in functions. So this function is actually built into the object, the daily production object. This is a built-in function. So it will sort the values in this variable. And the output is also series. Okay, now if I do sort values, it is sorting all the values in ascending order along with the keys or the index. And if I just print daily production again, obviously the original object did not change because these are not in place methods, right? This is ascending, and if you want descending, you just choose ascending equal to false. How do I know the parameter name? We have to study the documentation, guys, right? So whenever we are using any function, method, whatever, please go look at the documentations. Okay, so there's a parameter called ascending, which by default it is true. So if you want descending, then make it false. So then if you use the method, now it will give me descending. Again, this is not in place, so my actual object did not change. If you want descending and you want to change the object, notice that this method sort values, again there is this parameter in place equal to true. Notice many methods, wherever we are working with pandas, you will get this in place parameter. Okay, almost all methods will give you the in place parameter, and default is false. Okay, so if you want to change, you have to put equal to true. So let me do descending and let me change in place. So, and notice one more thing, when you choose in place equal to true, it does not display the output. Okay, understood that? So when you just do this kind of method, it gives you the temporary output. Okay, but when you put in place equal to true, it does not give you the output in the same execution, because it has gone and changed the object itself. So now if you print the object, as you can see, the object has changed. Okay, okay, there are also the other methods are also similar. You have sum, you have mean, those kinds of things. So if I say, hey, what is my total production in this week, just take the object and do dot sum. Total production is 8490 units. Great. What is my average production in this week? Dot mean. Okay, 1212 units per day is my average production in this week. Okay, great. So all of the numerical methods, statistical methods that we studied before, right? Many of those are directly accessible in pandas objects. Okay, now I want to show some more interesting things here, why this was built on NumPy. So suppose I have one series, I have these people here, Asif, Bhairavi and Chad, right? And suppose this is their expenditure in a hotel. Okay, so on Monday, these three people spent this much money on the hotel. On Tuesday, these three people spent this much money in the hotel. So suppose I build this series, data, index and name. Okay, so now I have series 1, it says Monday. These are the expenditures of these three people. Okay, and series 2, Tuesday, these are the expenditure of these three people. Now if you add these to these, what is your expectation? The expectation is that I need to get the total, which is exactly what happens. If I just do series 1 plus series 2, it adds the values, right? It adds the values and then it gives me the total. Okay, similarly, plus is not the only way to do the operation. There are object built-in methods like dot add. Okay, this is an object built-in method. So you can choose series 1 dot add series 2, or you can also choose series 2 dot add series 1, because addition is commutative. That is the word, right, in mathematics. Symmetric, commutative, something. It's a commutative operation. The order doesn't matter, right? So series 1 dot add series 2 to get the same thing. And notice our output is also series. Okay, series 2 dot add series 1, exact same. Okay, now one thing to note is that all of this is working very beautifully because index is proper. So suppose I have series 1, Asif, Bhairavi, Chad, and suppose I have series 2, Asif, Bhairavi and Colin. Obviously Chad and Colin are different people. Okay, now my series 1 and series 2 have 3 elements each, but here it says Chad spent 187 on Monday, Colin spent 202 on Tuesday. What will happen when I add the two series? So if I add the two series, this is where you start getting not a number, right? We discussed this NAN business in last lecture or something, right? So pandas expects proper strict indexing, right? This is critical in data science because you don't want to mix Chad information with Colin. You don't want to mix Colin information with Chad, right? The basis of data analysis, data science is integrity of data, isn't it? So by default, no pandas method will allow you to break that integrity. It follows very strict indexing. So what it will do is it will create a new series and it will say Chad I don't know, Colin I don't know, right? It Asif and Bhairavi it knows, so it will add. But Chad and Colin it doesn't know, so it will just say I don't know, nan, not a number. Okay, so notice there are multiple safety checks and foolproof procedures when you use pandas, right? So that we don't break our data basically. So anyway, what we have done, see, we've introduced ourselves to pandas by looking at series. We understood that it is strict indexing. You can give index labels. You can perform all the operations that you did with NumPy, right? This is all we saw that, right? So my point is that now we'll get into data frames and discuss in much more detail, right? And all the methods and operations you learn in data frame you can use in series, and you are encouraged to explore this further. Okay. As I said, the most common data structure in data science from the Pandas library is the data frame object. Essentially, it's a table of series with a common index. We will see what this means in more detail. Before we go to next section, let's do a bit of quizzing here. Okay. Can everyone solve the first quiz? See, and I've given all of these things here so that you can, save time. You can just copy this 3, and as long as there are no errors in this, then you can directly run this. Okay. So consider the series here. I have customer names, I have customer bill, and I've given the command to create the series. So cust info is the series. Okay. Use any series operation that you understood to find out which customer spent maximum amount of money. Share your command in the chat. So you can use NP matrix if you want, but as I said, arrays are more powerful. That's why we didn't study NP matrix only. Okay. So I've given you the documentation link for matmul. Okay, check it out. It multiplies matrix. It uses arrays as for matrix multiplication, not scalar multiplication. So typically we don't even use np.matrix so much. We just use np arrays. Everyone is saying cust info idx max. Yes, this should give you Monisha, I believe was the answer. Let's check it out. So if I just do this, yes, Monisha, wonderful. Okay, can we try the next quiz then, guys? Same thing. You have the same information as before, but now you have some additional information. Okay, so here you have customer names, customer bill, and this is the series customer info. Suppose that customers have already prepaid the following amounts in the hotel. Okay, so I have new set of values here, 500, 1000, 750, 500, right? The customers have already prepaid this. Now use whatever series operations that you have learned to find out which customer has crossed the prepaid balance. Okay, so Chad, Fareen, Himadri, Monisha, they've spent 256, 434, 109 and 529 rupees in the hotel, but they had already prepaid 500, 1000, 750, 500. So obviously, like, who has crossed their prepaid balance means what mathematically. Think about that and use series operations to output the answer. We went up until cust info, then obviously up to this point it is my original series. So if I just print this, right, cust info, that should give me a series. Okay, cust paid is a list. Now here, very good, right? We have now guys, see, now this is where I can see that you guys are understanding data analysis, right? You have converted the list into a series with the correct customer names. Wonderful, right? That is perfect. So now there is absolutely no way of going wrong. I don't care about the order of the numbers, whatever happens in backend, I don't care. Why? Because I have linked my customer names. In the original series, the customer name is linked with the bill, and in the new series, this prepaid balance series, the same customer name is linked with the correct prepaid values. So now all the information I need is already there. So prepaid balance, if I see, it's a new series. Chad, Farheen, Himadri, Monisha, 500,000, 750, 500. Wonderful. So all I need to do is compare these two. That's all. So that's what has been done here. Crossed balance equal to cust info greater than prepaid balance. Who spent more than balance? That's what you're asking. That's what this is, right? Cust info is the bill and prepaid balance is the prepaid. Who spent more than prepaid? And this logical is being used to get the is being used to subset. So I'll show that also in steps, right? So this is actually a Boolean series. So if I just print this, let me just print this here to show. So this is actually a Boolean series. Okay. So this Boolean series is stored in this variable. Now you can use this variable as an indexer, which is what is done here, right? So here say crossed customers equal to crossed balance, and then you are using the same logical to index it. Now notice that even the Boolean is a series, so it has index information. No problem. So you're using the values to subset the series, which is what is happening here. Okay, so this is subsetting this series, and the series index is what you will get from the index. Now if I just remove this index part and just print this. Okay, crossed customers. If I just do this, you will only get the subset where it is true. What is true? Which is true? Cust info greater than prepaid balance. So wherever the bill is greater than the wherever the bill is greater than the prepaid, only that subset you will get. So here, if I just do dot index, I will get the name. One step further, guys, if you want the string, just use bracket 0. Okay. One step further. If you want only the string, use bracket 0. Pick out the element inside the index. Okay. The index object is also list like object. Many of these objects are list like. Index, list, array. All of these are list like objects. Okay. So if you want the actual string, pull out the element. Okay. How to pull out the only element? Just index with 0. Okay. And now you can then print it. Wonderful. Okay. Whatever. Answer is Manisha. Great. Really nice. So we can start with data frames. Now I have a question to the audience. Do you want break now? Because then we can properly get into data frames. Or do you want break later? Please tell me in the chat. You can take it now, no problem. Okay. So it's 10:12. We can reconvene at 10:20. Okay. And I think again we have all the learners here. Before you go on break, guys, just reiterating the feedback that I gave in the beginning of the session. Please, if you can, give your feedback to us at the end of the session. Okay, that is quite valuable to us to understand what's going right and what we can improve. All right. So it's more of understanding the audience, right? So just keep giving that feedback for each session. It's really valuable. Just a request from our end. Anyway, we can go for a break now. We'll reconvene at 10:20 around. So see, a data frame is a two-dimensional table made up of multiple series. Okay, we will see how. But basically, these are many series put into one table, which is what we saw in example previously also. Okay. There are, as I said, many of the methods operations associated with data frames are also applicable to series. And no surprises here, right? Since a data frame is a two-dimensional version of multiple series, then of course, most of the methods will be shared between the series object and the data frame object. So suppose, how do you create a data frame? The command is pd.dataframe. Remember D capital, F capital, that is the name of the method, right? So if I just create a data frame like this, df equal to pd data frame, it executes, right? It executes, and if I just print, it gives me blank. Obviously, there is nothing in this data frame. It is blank. What is the type of this object here? Pandas.core.frame data frame. And as I said, we already saw this empty attribute in series. Notice that we can use the same attribute to check for data frame. So if I do df empty, it says true. My data frame is empty. Okay. Now, how to actually use data frames? See, the thing is that in data frames, we are talking in terms of rows and columns. Okay, multiple series. Where are these series? Each row is a series, each column is a series. Now, when we build the data frame, I'll explain a little bit in more detail. But right now, what you need to understand is that columns are usually features. Okay, the word that we use in data science is features. Okay, this is the word that we use, features. So and each row, the word that we use is observations. So features will be in the columns, observations will be in the rows. Okay, so for example, in this case, these are my features of the data set: customer ID, name of the customer, email of the customer, phone number of the customer, and total purchases made by the customer. These are the features. Okay, what are the observations? These are the observations for these features. So for example, I have this customer here whose customer ID is 001, name is Alice, email is something, alice@example.com, phone number is a string, that's okay, no problem, 1 2 3 4 5 6 something, and then the total purchase is 20. My next observation is this customer 002, Bhushan, bob@example.com, 987 whatever 15. Okay, so notice that this is a list within a list. So please remember back to two-dimensional arrays, right? So 2D arrays, if you remember, they were list within list, and each of these is rows, correct? Each of the lists within the list is one row. So right now this one row should appear as one row in my data frame. This should be my second row in my data frame, and so on, right? And these things are columns. So 001, 002, 003, that's one column. That should come under customer ID. Alice, Bhushan, Carl, this should come under name, correct? So that's how I set up my data. Now I say df equal to pd.dataframe and data equal to customer data, this one. This is the data, all the observations, right? This is my data. And columns are these names here: customer ID, name, email, phone, total purchase. Now I'll run this and I'll show you what happens. This is what happens. So if you see this list here, it has been taken for the column names: customer ID, name, email, phone, total purchase. And each of these observations is now stored in a row. See, 001 Alice, Alice at example, whatever, right? So each of these observations, each of these lists is stored as a row here. Notice that a generic index has been generated. Okay, so of course the integer index exists. Okay, even at this stage, customer ID, name, email, phone, total purchase, these are label index, which Pandas gives you the the option to do that, correct? Backend NumPy is storing integer index. So customer ID is 0, name is 1, email is 2, phone is 3, and so on. Same way, you did not give actually names to the rows. You gave the rows directly, right? Each observation you gave it directly. So what Pandas does, it takes the integer indexing in the backend, which is done by NumPy, and pushes it forward, which is why you're seeing here bold, right? 0, 1, 2 in bold. So whatever integer index is behind, it has been generated as the label index also. Okay. Because we did not specify names for the rows. Now, of course, there is a way to specify names for the rows. And for that, you can use the index parameter. So in data frame, the word index refers to the rows and the word column refers to the columns. Okay, that is the parameter names that you need to remember. So data is basically all of these observations. Columns gives you the column names, and then index, it's the index names. So suppose I use A, B, C, okay, customer index, and I provide that to index. So now I have data, columns, index. Now if I print this, you can see here the NumPy integer index went back and the label index is what you see, but the NumPy index is still there. Okay. Okay. So whether to use a standard integer index or whether to use unique identifiers like these, column names and things like that, that's a judgment call on the part of the analyst. Like, depends on what you're trying to do. If you're doing some very temporary backend analysis, then you don't really need proper labels for the rows and things like that, right? But if you're doing data reporting, if you're showing reports to the business team and things like that, definitely you need proper names for the index and the columns and things like that. Okay. Okay. So typically column names are something that we retain. Even if we are doing internal analysis, column names we retain because it's easier. So I need to know, feature analysis, one of most important thing, right? So total purchases, for example, if I have 1000 customers and I have all the total purchase value, I don't want to remember which location, integer location my total purchase column is. My data set may be having 20, 25 columns, 10,000 elements. Each time I cannot go find out where is my total purchase. But analyzing total purchase is important to me. I need to know what is average purchase. I need to know who did the maximum purchase. So to call that column, it's usually better to give proper column names in data analysis. Okay. Typically, it's good if you give both, but columns are more important to be named properly. Okay. Because as I said, these are the features that you are studying in data analysis. So that's what I'm doing here. I'm not giving the index name. Okay. And my data frame, I'm just redeclaring it without the index. So now I have integer index. Okay. What happens if my observation is not matching with the uh, columns? So for example, here Carl, I deleted Carl's phone number. I have Alice full observation, I have Bhushan full observation, but for Carl I deleted the phone number. Everything else is same. What will happen? It executes, but now you see what happens to the data frame. It produces not a number, none. Okay, and what it did was it took the 25 total purchase value and put it inside phone column, which is wrong. Correct? So Pandas cannot identify meaning like that. Pandas doesn't know 25 is phone number or 25 is total purchase. Pandas doesn't know that. So whichever order you put, same order will be matched with the customer columns, right? Same order will be matched with the column names. So typically it is suggested not to have this kind of data. You should make sure that your data is proper. Otherwise, as you can see, it will produce lot of missing values, right? And Pandas is not intelligent enough, obviously, to match 25 with phone number or 25 with total purchase. How can it know what is what? So it just pushes 25 to the left. Okay. Now what happens? Now in this case, at least it is producing NaN. What happens if you do not even have the complete column list? So here it says customer ID, name, email, phone, total purchase. Here I deleted phone from the column. What will happen? In this case, it gives me a proper error. It says, look, 4 columns passed, but data had 5 columns. And at this stage, Pandas will not accept this object, right? You gave me 4 columns, but your data has more. I don't know where to put. I don't know. Should I make a new column? Pandas doesn't know. So it throws an error, right? So typically, it is better if length of each observation and number of columns are matching. To avoid any interpretation issues, any data integrity issues, always it is better to match the lengths of the observations with the length of the columns that you're specifying. Now, I have shown you this method with nested lists and things like that. Typically, the dictionary method is used more often. What I have seen is the dictionary method is very clean. Same way, if you remember in series, we just passed the dictionary. The keys of the dictionary went to the index and the values went to the values, right? A similar kind of thing happens in data frame. Not exactly same, similar. So here what's going to happen, if you can see this dictionary here, notice that the key of the dictionary is actually the column name. Customer ID, name, email, phone, total purchase. These are the keys of the dictionary and these are the column names. And your complete column list now as a column vector, not row wise observation. Okay, so if you go back to any of these data frame, what is the column vector for customer ID? What is the column list? It is 001, 002, 003. What is the column list for name? Alice, Bhushan, Carl, right? That full column list you can pass as the value. So customer ID is the key in the dictionary, and then you have the value, which is a full list. Okay. So, and then the next key is name, and then you give the full list, Alice, Bob, Charlie, whatever. So now you have all the column names in the keys, and then you have all the values as column wise features in lists, and directly you can pass this dictionary to DataFrame command. And as you can see, very nice. Customer ID, these are my customer IDs, these are my customer names, email, so on. So notice how the column names are directly interpreted from the keys, and the full list of the rows for each column is interpreted from the lists that you give. So typically, this is a cleaner method to create data frames from scratch. Okay, and of course, if you don't like this NumPy backend integer index, you can always specify the index. So same thing if I do here. Now I can have as you can see here the labeled index for the rows. Okay, great. Now here and one last thing, as I told you, if you don't need to specify the parameter name each time, if you know the order. For that you have to study documentation, see the order, data first, index next, columns next, d type next, and then copy. Okay, forget about copy and stuff like that right now. Let me just run this, and as you can see, it produces this data frame. And by the way, as I said, you don't even need to put parameter name. So if I just have a dictionary like this, right, I can directly just convert it to a data frame. and it takes the column names and the observations and all of that. Right. So one thing to point out, see, initially in data analysis, data pre-processing is a place where we may sort of use some of these creation methods like dictionaries and lists, but majority of data analysis, you will be working on collected data, so in the program. But as you do the program fully, by the end of the program, you will be expected to know data collection, sourcing, and pre-processing, then analysis. You understand what I'm saying? So right now we will get into these, as I think similar to what Sonal was asking, right? So all of these different techniques we will be discussing topic by topic, and slowly when you do some of these projects, right, we have course projects and things like that, assignments, there you will be using everything, and by the end of the program you will be expected to know all the things, like sourcing the data, putting it together, cleaning the missing values. It's like there's a huge pipeline of activities, right, what a data analyst is supposed to do. So treat each session and understand what you're understanding from here. It will all be put together little by little as we go from topic to topic, and in a major way there are projects to sort of help you out in those things. Okay, so now we'll get into reading data. I think this is the fun part. So see, there are many read methods in Pandas. I am showing you read CSV, read Excel. You can go see the documentations. Pandas can read many type of files. What I have provided you is CSV files. Okay. Now, I don't think I gave you Excel access file. Don't worry. The same data is there in CSV. Please run this one and see if you are getting the buffet details. Can you confirm? Like, can you run this command pd.read_csv and then the name is already there? Is everyone able to read the buffet data? Please confirm. Sunidhi, yes. Anusha, yes. Shri Prakash, yes. Sauradeep, no. What's the problem, Sauradeep? Was there a Ashish, yes. Others, we are able to read it. Rajat, no. Can anyone just tell me why? What's the error? No such file. Okay, Rajat, what are you using? Colab or Jupyter? Then please check whether buffet details CSV has been downloaded into the same folder where you have the notebook. Sauradeep, please check whether you have uploaded the data file, CSV file, into the Colab folder. So on the left side, you have some menus, right, in Colab. So there you will see a folder icon. You need to drag your file and upload it there. That's for Sauradeep. And for Rajat, just go to your system folder, wherever you downloaded the notebook. Just check in the same folder whether you have buffet details.csv. Okay, these are the advice I can give you guys based on what I can see from your responses. Okay, right. Now what I want to sort of show here is that, see, there are some parameters of this read function, file path or buffer and then things like that. And see, when you deal with different types of data, it will ask for delimiters, right? So what is CSV? Comma separated variables. Okay, CSV means comma separated variables. So this CSV is an Excel CSV. So it is storing as comma separated using Excel. You can have different delimiters. Okay, you can have space delimited, comma delimited, so on and so forth. All of this will be explored a little more detail when you do data sourcing and things like that. Right now, we'll just read the file. Okay, so read CSV has that parameter file path or buffer, which is where I gave my file name. Please note that this is not file name, it is file path. So the only reason that my code is able to read this file is because this file is in the same folder as my code. If the file was in a different folder, you can just provide the file path. Okay, so that's something that we'll not get into in this session, but you can Google it and read more about it. We will see file paths, things like that, in a later data pre-processing, things like that. Okay, so The reason that this is working is it's in the same folder as my code. Now there's another very nice parameter that I typically like to use. So if so look at the data, okay? The data has room, A1, A2, A3, A4, name, Shilpa, Jaspreet, Dominic, Ahmed, age 1832, 1922, cuisine, Indian, American, whatever, expenditure 24, 18, 27. These are in dollars. So what is this? This is basically the amount of money spent by these people, and then it, in a hotel, right? And they have also stored the room number which they are staying in, the age and the cuisine. Okay. So now here, just do one thing, right? Just make a new cell here and write pd dot read csv and put empty brackets. Just do this much. Can everyone tell me after doing this much? Just say yes. Create a new. Okay, 1 second. I think some sharing issues. 1 second. Yeah, okay. So everyone created a new cell and you wrote pd dot read underscore csv bracket. Correct. Now you can just press tab. Okay, and it will give you all sorts of things. Don't worry about that, right? Instead of tab, what you do is you put string. Okay, put string and then write just the first few letters. So I have written buf. Now if I just do tab, it is going to show me all the files that has been recognized by Jupyter. So if you just put string like this, just make a string and then tab, it will show you all the string objects, which is not good, right? So usually I just put 1 or 2 letters and then you press tab. Now Jupyter will show you everything, right? So where were we? We were reading this buffet detail file, and as I said, the buffet details, what it has room number, it has name, it has age, cuisine, expenditure. What again? Each row is an observation. Okay, so the first observation is Shilpa, who is staying in room A1, whose age is 18, who likes Indian cuisine, and she spent about $25 on Indian cuisine. Okay, and similarly, you have all the different observations. Jaspreet stays in room number A2, age 32, and spent $18.54 on American cuisine. Okay, one interesting thing I like about PD read CSV and typically reading functions in Pandas, it allows to set the index column whenever you want. So notice that again here, what happened? It has so if you open the CSV file, which I'm not showing right now, but you can open it using Excel or something, it does not have these numbers. The 0, 1, 2, 3 is not there in the data. Okay, these are the NumPy indices, correct? So the 0, 1, 2, 3, 4, 5 is the NumPy backend integer index. So what Pandas does, it gives you option. If you want to set one of these features as the index for the data frame, Pandas allows you to do that. So there is a parameter called index underscore column. So again, if I do pd read csv and file path buffer, this is my name path of the file. This is the same, right? Same as before. I can specify index column to be one of the features. So if I say name, and then I read the file, now the index is name. Okay, and that feature is now not there inside the data frame. It has become the index. So one of the features you can overlay on top of the NumPy integer index. So now name is here. Also, name is a very bad index. Okay, I hope everyone can understand. Two people can have same name, right? So name is a very bad index here. What is a good index for this data set? Room is a good index for this data set because room is unique. As a hotel manager, you are interested in unique identifier. So room 1, room 2, room 3, right? So I have shown you index call equal to name, but obviously it's not the best index. Room is a better index. So for example, I can read, I'm using another function, read Excel. For you, it may throw an error because I did not give you the Excel access version. So you can just comment it if you want. But I'm just showing you that it works. Okay, so if I read Excel buffet details.xlsx with index column equal to room, it will print for me the same thing. You can read without any commands also, you can directly read. Okay, so finally what I want everyone to do is execute this command. Okay, all these different other versions we will not be using. We will use this version. Okay, so just do df equal to pd read csv buffer details dot csv. Okay, and then print the data frame and confirm that we have this. Please confirm in the chat. Okay, great. Okay, so please solve these two quizzes, right? Load the car prices.csv into a data frame with the name df cars. Okay, and study it. Study it means don't worry, we'll study it. For this, don't specify the index column. What is the command? Do not specify index column. Read this into a data frame name with df cars. Can someone give me the command? So this has 205 rows, 21 columns. I hope you can see it gives you all the details here. 205 observations, 21 columns, and there are many columns obviously. So everyone able to read this file? Yeah, perfect. Yeah. Okay, then do the next quiz, please. Load the user movie rating CSV into a data frame named df movies, and this time specify the index column as the user. For this, you need to know what is the name of the column. Okay, so what you need to do, if you don't know the name of the column, what you need to do, either you go and open the CSV file and check there, or you read without specifying the index column to see the name of the column and then read with the index column. Okay, so basically you need the name of the column. Everybody able to do this? The first thing I would do here is pd.read CSV, and I'll just copy this here, right? And I will see the name. It's saying specify the index column as the user. So user means Arnold, Ben, Catherine, Disha, Euclid, whatever. So the name of the column is user. So I can just print this temporary output, copy this column name from here. I will say, one second. I will say here index column equal to string user, and here I will say, I mean, you don't need to give the parameter name. It will work. So this I want to store it as df movies equal to. Okay, I'll print it. Everybody able to do this? Index call equal to user. Yeah. Okay. So the whole point of this is that you need to know your data, right? Again, guys, I told you data analysis is not just about analyzing data. It's also about handling data, right? So we are getting a lot of first-hand experience here handling all these files, file path. This is all very important in data science. Okay. So great. The index column I have specified as user, which is the name of the column here, which has the users. Now I want to go through these two data sets, then we'll move on. See, this dataset car prices, what it has is it has 200 cars of different models. Okay, so you can see car name Alfa Romeo, Audi, something Volvo. All these are car types or names. Okay, then you have various features like number of doors, type of car body, engine location, wheelbase, car length. This I think is inches. Car width, again these are in inches. And then you can see dot 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 because there are too many columns to display. Okay, so we can't see all the columns here right now. It's giving me number of cylinders of the car, engine size, bore ratio, all sorts of things. And then, you know, one of the most important feature is the price of the car. And I think this is in dollars. You can also see mileage, miles per gallon, right? Obviously this is not metric unit. This is American unit. But yeah, miles per gallon mileage is here, highway mileage, city mileage, horsepower, all these things. So this one is actually, you know, a fairly standard data set. It's a real data set which is used to you know train ourselves in data science. It's a very nice data set. It has many type of feature and really nice. This other one, this is a smaller data set slightly. What it has is it has usernames. First, let me just print without the index column. So what it has is it has the usernames here: Arnold, Ben, Catherine, Disha, Euclid. It has a few movies: Thor, Justice League, Spider-Man, whatever, you know, Casablanca, Kissing Booth, Annabelle, Insidious. So it has the ratings given by each of the user on a scale of 1 to 10 for these movies. So Arnold gave rating 6 to Thor, 5 to Justice League, 6 to Spider-Man. Clearly Arnold does not like action movies. Ben gave 9, 10, 8 to Thor, Justice League, Spider-Man. Ben really likes action movies. So on. right? So 1 to 10 scale, you have ratings of all the different movies by these users. Okay, so let me put back the index column. All right, so everyone was able to load both, right? We can move on with studying data frames now. Please put yes. So to study data frames quickly, right? There are some very interesting, nice methods. One of the method is called head, and notice these are all built-in functions. Okay, so this object called df, which is where I loaded the cuisine thing, right? That object has multiple built-in methods. By the way, these methods will work for series also. Go try later. Okay, so df.head, what does it do? Basically, it gives me the top 5, right? First 5 observations of the data set. Why do we need this? Of course, our data may be very big, right? Maybe we have thousands of observations. So if you quickly want to know what does my data look like, then you can use the head command. Okay, and here you can specify how many observations you want to see from the top. So if I say df head n equal to 3, then it will give me the top 3. So top 3 means first 3. So 0, 1, 2. Okay. Similarly, there is a tail command. This gives you the bottom. Default is 5. Okay, default is 5. So 1, 2, 3, 4, 5. So from the bottom, it gives me 5. Again, you can specify from the bottom how many you want to see. df.tail. What are the things we need to remember here? 1, the output is a data frame. 2, these are not in place operations. Main things that you need to remember with these commands. Output is a data frame. In place, not happening. So if you now quickly just print df, of course your original data is still there, right? Purpose of data analysis is to analyze, right? Of course, when you want to mess with your data, you can do that, but typically you want to analyze what's in your data, study what's in your data. So a lot of methods, as I said, will not change your original data. Okay, so head and tail. Now again, if you want to know the axes of your data frame, I told you there are 2 axes, right? One is the rows, and one is the columns, right? So it shows you here the observations, the index of the observations. Right now it is a labeled index of 0, 1, 2, 3, 4. Why? Because we did not provide any index for the rows. So what is happening? The numpy integer index 0, 1, 2, 3, that is being pushed forward. So that is what is being shown here. Okay, and what about the column? Column is here: room, name, age, cuisine, expenditure. So this rows go from 0 to 9. Okay, so stop equal to 10 means exclusive. Okay, 0 to 9, and then index for column is room, name, age, cuisine. Don't get confused with the word index. Okay, that's why I said this is called observations and this is called features. This is an index object. This is also an index object. Both are indices. According to NumPy, both are indices, right? But in Pandas language, that changes little bit. So if I do df.index, it will give me the row index. So for NumPy, index means everything. First dimension, second dimension, third dimension, whatever. For NumPy, all are index. For Pandas, df.index specifically, that variable name is, attribute name is reserved for the rows. Okay. And here, of course, there are 9 observations. So you can directly check len of data frame. Length gives you the rows. Okay, len, not 9 observations, 10. So length of df gives you 10, right? For columns, what do you do? df.columns. So if I do df.columns, this attribute provides me the column index. So again, no confusion. Here the I is capital. This is index object. Here the I is small. That is index attribute of the data frame. Okay. And as I told you, this is all NumPy based business. So df.shape should work. I have 10 observations. I have 5 columns. df.size also should work. It says 50. df.size, why does it say 50? All the number of unique elements in my data frame. So 10 into 5 equal to 50. So totally I have 50 data elements in my data set. You can also check df types. So for each feature, it will tell you what is the data type. So room has been loaded as object. So room, if you see, it is A1, A2, A3. Ideally, it could have been string, but Pandas has loaded as object. Okay. Name is object. Age is integer. Expenditure is float. Obvious, right? Age are all integer values. expenditure or float values, and so on. Now, typically, there is this one very powerful method to study the features, not feature, characteristics of the data frame. It is called info. So df.info, and notice this is not an attribute. This is a command. So you need to put info with brackets. Okay. So if I just do df info, it gives me all sorts of quick characteristics of the data frame, right? It tells me what are the columns. Okay, it tells me how many values each column has which are not null. It tells me the number of rows. Okay, so number of rows is 10. It also tells me what is the row. It is 0 to 9, right? And since I have 10 rows and each column has 10 non-null features, that means there is no null value. There is no missing value in my data. It also tells me the type of each of the feature: object, object, integer, object, float, right? And it also tells me how much memory it's right now using. To store this data frame in my local system, it is using 532 something bytes. Okay, very powerful method, df.info. Okay, very powerful method. So typically these are sufficient. See this shape, columns, index, info. These are sufficient to study important characteristics, but there are some methods which have been imported from NumPy, which gives you similar things like df.keys. If I do, it gives me the column, df.values, it gives me each of the observations. Typically we don't use these so much, but these also exist. So in some situations maybe it is useful. So df values giving me all of the observations, right? And df keys gives me the what is this, the column names. So this is again the, if you remember when we created data frame, we gave data equal to something list within list, right? And then we gave columns equal to this, right? So those keys and values we are getting here. Typically it's just easier to use these methods: shape, column, index, info. Okay, some cases maybe you need this, but not very frequently. Okay, so okay, I want everyone to run this now. So if I do temp df, just please run this command. Okay, this time we are reading the buffet details, but this time we are specifying room as the index column. Okay, so read this and let's call it temp df and then print temp df. Can everyone tell me, are we getting this with the room as the index? Okay, great. Now again, if you do the same method, what will happen? So if you do head will still behave the same way, right? It will only give you the first 5 values of the data frame. Now if you do shape, notice that it is 10,4, not 10,5. If you do shape, you get 10,4. Why? Because your room feature has now gone and sat on top of the integer index for rows. So that feature is now an index for the rows. So now the shape is 4. Okay, so 1, 2, 3, 4. Name, age, cuisine, expenditure. Why? Because we use room for the index. Now if you do temp df.columns, you will not find what is that, room. Room you will not find. Okay, and if you do temp.index, here you will find name equal to room. Interesting, right? So room we have used as the index column. df.index, if you do temp df.index, if you do, here it says name equal to room, and here is the value. So data is not lost, it is there. So if there's a very, we'll do some methods later. There's a very nice method. You can just pop out this room feature back to the data set and push forward the NumPy integer indexing back. Okay, it's all there, right? Here if you do info now, what does it do? Very interesting. See this. It says my index is 10 entries starting from A1 to A10, and it says I have 4 columns. Okay, so we are all understanding what's happening here with the data frame and studying the data frame properties. Okay, now another thing, a few other things. df.dtypes, this I don't think I showed you, but info gives me data type anyway. So if I do info, I will get the data type. But if you want the data type separately, you can just do df.dtypes, and that gives me the data type for each feature. Okay, transpose, same as NumPy. What will happen if you do df.transpose? As you can see, columns became rows. Okay, now the columns are 0, 1, 2, 3, whatever, and now the rows are room, name, age, cuisine. Okay, so now if I do df transpose d types, what's going to happen? It will give me the d types of the columns. So you can see here column 0 object, column 1 object. And why is this object? Obvious, because in each column you have integer, float, string, you have everything. So as far as Pandas series is concerned, it is object data type. But at the same time, each element still retains its data type also. So you have not lost your integer information. You have not lost your float information. Yeah. So again, what will happen if you use temp df now? You remember, this is the data frame in which we have, what is that? The room as the index, and just do transpose. What happens? Now the room becomes the columns, and then the previous columns, whatever name, age, cuisine, this become the label of the index. Okay. So basically what this shows, what this whole thing, what we learned is that, look, Pandas data frames are nothing but intersection of series. Okay. Think of it as a 2D array, but each slice is a series. Each slice. So A1 Shilpa 18 Indian 24.65. That's a series. Name Shilpa Jasprit Dominic Ahmed Joseph Saju Monica. That whole thing, that is one series. So it's essentially collection of series, and a pair of series will intersect at an element. So room number A5, how much expenditure? $17.32. Okay, so pair of series intersecting at an element. Okay. Okay, time for quizzes. Please solve these right now. These are pretty straightforward. Print the top 4 observations in DF cars. How do you do that? I want to see some commands in the chat, guys, please. Print DF. Interesting. You don't need to print each time. Maybe I don't even know what result you're getting. Yeah. Don't do print. Don't do print. It gives you little weird result. Pandas already has a nice way to print it. So just directly do df cars.head. Of course, you can use print if you want. The result is just looks very weird. Okay, great. Next one. What about bottom 6 observations of DF movies? Yes, DF movies tail 6. I'm just going to copy it from here. Great. Wonderful. Nice. How many rows and columns does DF cars have? How are we going to solve this? How many rows and columns? What command should we use? How many rows and columns does DF cars data frame have? There are many ways to solve this. Very nice. Num rows, num columns equal to DF cars. Brilliant. Yeah. Info is also good. Typically, I would have said info, but Sunidhi has given much better answer. I'm going to take that. By the way, guys, I'm also part of the group who will use info. Okay, I will just do df info and I will check. Okay, it has so many rows, columns. But Sunidhi's code is really nice, so I'm going to take that. Okay, num rows, num columns equal df chorus shape, and we know that it's a 2-dimensional array. Shape is going to have 2 values. First value is number of rows. Second value number of columns. It's all NumPy business. Yeah, and I can just print it. Say print, and then I'll print this tuple. 205 rows and 21 columns. This is one method. Another method, df.info. Quickly check it. Array, not df. I'm very sorry. Df cars. Df cars.info. 205 entries. Okay, and 0 to 20, which is here 21 columns. Okay, 205 entries, 21 columns. Another method, just print it. If you just print df cars, you can see at the end here 205 rows, 21 columns. Okay. Okay, quiz number 6. What are the data types in DF cars data frame? What is the command we'll use? I mean, other than info. As I said, info gives you like almost 80% of what you need. Okay, how do you get the data types of the features in DF cars? DF type frame what? Shouldn't work. It's already there. Okay, I think the answer is already there. Whatever. So just print df cars.dtypes. I don't know where this came from, guys. Yeah, df cars.dtypes. Now, is everyone able to print that? Df cars.dtypes. Did we print it? Yeah. So in that, now you can see very nicely. You can see all the features. car ID integer, symboling integer, car name object, whatever. Great. Yeah. Wonderful. Okay. Now comes accessing. Biggest pain, isn't it? NumPy accessing. Now pandas accessing. Okay. All right. So in this section, we will study access methods. We'll focus a lot on the fundamentals here. Okay. And some of the important other methods we will go in detail, but we'll kind of do it in an introductory way, because accessing is something that we will study in detail in pandas session, right? Later in topics such as data processing and all of that, the other methods you will anyway be using more and more often, in data visualization, data analysis, data processing. In all of that you will be using some of the other operations and methods more and more. So this is the right time where we should learn the accessing. Okay, fine. Let's print df. This is my buffet data. Now suppose I want to pull out the column called room. Okay, so one way to do that is you can use the key name, which is why here room with a capital R is actually an attribute of this data frame, right? Because it's part of the list of keys. This is not typically used so often. You will find that, okay, this is one way of accessing the columns which is used sometimes, but here if you notice, all the column names are a single word. If your column name was two words with a space, then you cannot use this method. So for example, room number, if that was the name and then there's a space, then of course you cannot use this kind of method. But if you have a single word for the name of the column, you can extract that column. What is this object? What is this right now? Can everyone tell me? df.room I have printed. Can you tell me what does this look like in the chat? We have seen this data structure before in this session. Exactly, it's a series. So now if you just check the type, pandas core series. Okay, hope it's making sense now, right? No magic going on. Whatever series are there, each column is a series, each row is a series. So you pulled out a column, you got a series. Okay. Okay. Another way to access column is this. Okay, single indexing, indexing method with the square brackets. So if I just say df and then say the column name, it will give me the age column. So you can see here 1832, and the index it is giving is 0 1 2 3 4, because I did not specify a separate label for the index. So that same index is coming 0 1 2 3 4. Okay. Now if you want to retain the shape, we already saw in NumPy what you need to do. You need to use square bracket 2 times. So now if you use square bracket 2 times and you use age, what's going to happen? It is going to give you a data frame. Okay. So this is a data frame with one column called age. Okay. If you want more than one column, then you can use methods like this. Now one problem you need to remember is that this format in Python, remember, it is a tuple, isn't it? This a comma b business in Python, it's a tuple. So the argument to df is not a tuple. Okay, the argument to df should actually be a list in case you have two items. So if I want to get cuisine and age, then I have to create a list which has the two column names, and then I have to access with another square bracket. Okay, now if I do that, I will get both cuisine and age. All right. Now suppose I pull out df cuisine. So let me just just get cuisine from here. How do I access the first element? Just remember NumPy. Okay. So if I just do bracket 0, it will give me the first element, Indian. df cuisine, this is the series. So df cuisine 0 means what? The first entry in the cuisine feature. Okay. Notice that this is an integer right now. Okay, it's an integer. So here I have put string 0. This will not work. Obviously it will give error because it's a key error. Okay, the word key in Python is used typically for indexing, right? So the key is pointing to some object. So here the integer 0 is pointing to this object called Indian. Okay, and we remember that, I hope we remember that this is the 0 1 2 3. Where did this come from? I did not specify. It is the NumPy integer indexing which has been pushed forward. Okay, so that is why if you try to use a string here, it will not work. Only the integer will work. in case that it was a string with 0, or suppose instead of 0 you can say a1 a2 whatever, right, the other data frame, then you have to specify it as string. For example, here temp df, if you see, the index is room a1 a2 a3 a4 a5, and we have name age cuisine. Now suppose I pull out temp expenditure. Okay, suppose I pull this out, temp expenditure, it is a series. Notice that now it is retaining the label, right? And don't say that it is not retaining label in previous case. It is. The only thing is that you did not give any index label for the rows. So numpy 0 1 2 3 has been pushed forward. So in a sense, you can think of it like there is a layer in which there is integer index. On top of that layer, there is a label index for both rows and columns. Okay. In the temp df case, now I pulled out this expenditure column. Notice that the integer indexing will also work and the label indexing will also work. Okay. So if I do bracket 0, it will give me 24.6. Why? Integer indexing still it is existing. Okay, in the backend numpy. And a1, will this work? Yes, pandas. Okay, the label indexing also works. So there are two types of indices. In pandas data frame, there are two types of indices. In numpy arrays, there is only one type of index, integers. In pandas data frame, there are two types. The integer indexing, on top of that, you have the label index. Okay, very powerful data analysis methods, right? So yeah, the point about this is that, you know, this kind of accessing may seem clean. Okay, this kind of accessing may look clean, but it is not. Let me show you some proof why it is not reliable. Okay, so suppose I do temp df a1, error. Why error? Because there is no such thing as a1 in the column. If you see this, it's all row index, correct? Okay, so suppose I do you know, df0. If you remember, why is df0 also not working? Check df, right? Df should have a 0. It's not working, right? Df0 is not working. It's probably going to say key error. See here, key error, right? And here also it's saying key error, right? What I can do is probably transpose it and then access 0 if I want the row, right? I can do that. And for temp df also I can do you know, transpose and then get it, right? But this kind of, obviously, why should I transpose my data and get the row and things like that, right? Why should I do that? In fact, you know, let's just look at, for example, let's look at temp df. Suppose I want the first row. Okay, suppose I want the first row. Now I've obviously shown you that temp df indexed with a1 is giving me error. Okay, so maybe you think that, okay, what if I do you know, temp df bracket colon a1 something, right? What if I do this? Absolutely not. Okay, it's again going to give you error because I just told you tuples are not allowed. Okay, let me put it in a list and, okay, invalid syntax. See, so this kind of indexing may seem clean, but it is not reliable. It is not powerful. Okay, so this is called direct access. It is okay sometimes to pull out the columns, and then from the column you can pull out things because one column is a series. So from series, then you can access again like a series, right? It's okay in some cases, but the more powerful methods are something that we will see soon, right? Which I will mention soon. But first, can we solve these quizzes? Okay, let's solve these quizzes, guys. Access the car names feature from the df cars data frame. Okay, so first print the data frame and then see what you want to pull out and pull it out. Please give the command in the chat. Just print it, no need to assign it, Sunidhi. So directly you can just so for example, df cars dot car name. That's all. No need to assign. That's one method. Any other method? Waiting for answers in the chat, guys. Any other method? Next, quiz number 9. Access the movie ratings for the movies Thor, Spider-Man, and Insidious from DF Movies. Prakash, that is correct. Again, is that a comma? Yeah, fine. I also make all these mistakes, guys. Dot, comma, colon. Just this is a practice, right? More practice. Sri Prakash is correct, by the way. I'm just saying that I've become used to checking each syntax. Okay, next quiz. Next quiz. Quiz number 9. Access the movie ratings for Thor, Spider-Man, Insidious. DF movies. Anyone? So I'm just going to copy the command in the chat and put it here, guys. Right? I want to see. I want confirmation. Okay, I'm copying. Pratim, you are giving me previous quiz answer. I will take Ashish's answer here. DF movies, Thor, Spider-Man, Insidious. Okay, wonderful. And I hope everybody is getting this output. Yeah. Okay. Okay. Notice that, and again, guys, keep remembering things like this. Okay, the output is a data frame. So what? So you can chain commands. Just for example, I'm saying. So now the output of this subset is a data frame. I can definitely do dot head, right? So, and the output of this is also data frame. So now I can do dot tail suppose 2 gives me Disha Euclid. You can chain commands, man. So now I do, okay, I just want Disha dot head 1. This is also data frame. Okay, I want Spider-Man. Now it's a series. Well, it's a series. I just want the first value. Answer is 7. So notice, okay, you should, by the way, chain commands. Okay, more speed and more efficient analysis. It may be hard in the beginning, but I told you the easiest way. Just remember what the output is. Output is a data frame. Okay, I can use some method. Output is a series. Oh, I can use another method, right? So you can chain all of these things. Okay, anyway, now we will move on to, as I said, this kind of indexing is good some cases like these. But if you really want a strong indexing, then we have to do, we have to go through as much mental effort. Yeah, Shri Prakash, that's how it is, right? So, I mean, see, the whole point of data science and everything, it's like if you are enabled with the tools and the math and everything in the beginning, then after that it becomes good. So what I'm trying to say is, if I directly taught you, Shri Prakash, if I directly taught you some data analysis, I would not be able to fully impart, what I'm trying to say. But if I teach you the math and the programming and the NumPy and all of that, and then when I teach you some data analysis, you will understand what exactly I understand, right? So that's kind of the reason that the program is designed in this way, and kind of the reason that the initial part we have to put a lot of effort in getting familiar with the tools, the programs, the math, and those kinds of things, right? Anyway, thanks for pointing that out, Sri Prakash. Okay, so this kind of indexing method, direct access, it's nice, it looks clean, but it's not powerful. So in Pandas, we have two powerful indexing methods. Okay, one is called LOC, location, other is called iLoc, integer location. I think the second one everybody knows what it is. iLoc, it is NumPy integer index, full stop, right? Then if you know what iLoc is, then you know what LOC is. What is LOC? It is the Pandas label. So A1, A2, A3, A4 column names. That's all. So now let us see how to use this. So suppose I take my buffet thingy, right? And suppose I also take the buffet data frame with room as the index. So I'm taking two versions. Okay, I'm working with this version of buffet in which the uh, row indices are just copies of the NumPy backend 0, 1, 2, 3, and in this version the row indices are labeled. Okay, so df.loc 0. If I just do this, what I will get the first observation. So df means this data frame. So in this df.loc 0, 0 is the name, and notice the language I'm using, name of the first index element, not number, name. The only reason it is working is because NumPy index was pushed forward. So df.loc with the name of the first element in the row index. In this case, it is 0. In df case, it is 0. That will give me the first observation, which gives me the series A1, room number A1, Shilpa, 18, Indian, 24.56, whatever. This one, right? The first one. Now, what about tempdf? Can I try tempdf loc0? Let me just try tempdf loc0. It gives error. Why? Because it's a key error. LOC is expecting the pandas label, not the numpy label. So in tempdf, what is the pandas label for your first observation? The pandas label is A1. So if I do tempdf.loc A1, that will give me the first observation here, Shilpa, 18, Indian, whatever. Okay, that is pretty clear. Fine. So the LOC indexer is not exactly positional, it is nominal. Nominal meaning name. Okay, positional means very strictly positional, it is your integer index. Okay, so for that there is a separate method. The similarity to numpy is that the first, if you give a integer, not integer, if you give a single element as the argument for LOC, then it will take the row, 0th dimension, it will take the row. Okay, if you want the column, for example, if I just print here df, right, and I want the column age, so you may think, okay, df.loc age, let me do that. No, age does not exist in the rows. If you give a single element, that is the row indexer. So age, if you will get a key error because age does not exist in the rows. So now remember numpy. How did we do the column access? We did colon, comma, and then you give the name, right? Colon, comma, name. Now for numpy, it was all integers, correct? For pandas, this works with whatever name you give to the columns. So here I have to do df.loc. What does this colon mean? It means give me all the rows, right? It gives me all the rows, comma, give me the column age. So now it will give me all the rows for the age feature and the output is a series. Okay. So the LOC indexer defaults to observations if the argument passed is not a tuple. Okay. Now, for example, if I want one element, suppose, so as you can see here, this df.loc age, this is a series, and suppose I want, this one 32. So what I can do is I can do like this, right? df.loc colon age, this gives me this complete series. Now I know that the output is a series, therefore I can use bracket 1 to access the element 32. This whole thing you can combine as a tuple, right? So df.loc 1, right, row with name 1 and then column with name age. Now similarly in tempdf, what you should do in tempdf, remember that the names are strings, proper strings, a1, a2, a3, these are strings. So here if you want age of the person in room a1, which is 18, so I can get it by tempdf loc a1 comma age, which is 18. Now if I want all the details of the person in a1, then I can just do tempdf loc a1 comma colon. In fact, you can directly do tempdf.loc a1. This also will give you same. I usually do this. I mean, if I'm doing very quick analysis, maybe I do this. If I'm writing a more bigger code, I might do this, right, for consistency. And if somebody else reads, they will at least know that it's a tuple. Okay. Anyway, so you can also, so this is, we know all this. This is all NumPy business, right? Same way, if you want, age and expenditure of the first element, first observation in df. Notice how language is getting hard. If I do not give name label to rows, the data analysis language is getting harder. I'm saying first, 0th, second, third. Isn't it easier to say, get me the expenditure of the person who stays in room number A2? Much faster, much easier, right? So that is the transition from NumPy to Pandas, right? From mathematics to data analysis. So anyway, we will study both in this session, as I told you before, right? Then slowly you can transition into the analysis part. So here, if I say, okay, get me the age and expenditure of the person whose details are in row with name 0, right? So then I can do df.loc 0 and then put age and expenditure in a list. So now it's a tuple. Now this is the, so in NumPy also we could specify that, right? So inside the tuple, The first element is the row index, second element is column index. The second element you can put a list with the column names. So here I put age and expenditure and I put 0. Now I'll get age and expenditure for whoever is in observation named 0. Okay. For example, in tempdf, if I take tempdf now, and I want the age and the expenditure of the people who stay in room A1 and A7. Then that's very simple. Tempdf loc, create a list with A1, A7. For the rows, create a list with age, expenditure, print. You'll get A1, A7, age, expenditure. Okay. Now, if you want continuous slices, that also you can do. Right. All of this is imported from NumPy access. Okay. So if you want continuous expenditure, continuous access, you can use the colon method. Notice here we are using colon with strings. See, typically this should not really give me an answer. It should give me an error. If I just do string colon string, that makes absolutely no sense to Python, right? These are not ordinal, numeric. They are nominal. They don't have position. They don't have location. Location they have. They don't have ordering, right? So it's giving me error. But if you put this slice inside LOC, it will work. So Pandas is able to interpret that. What it's going to do is going to take from A2 to A6 and it's going to print all those observations. So suppose I want age and expenditure for all the people who are staying in room A2 to A6 and I print this. It gives me from A2 to A6. Now I want everyone to look at this result. Can you please tell me one small difference between NumPy and Pandas in this specific example? Can you tell me one small difference? Anyone? Notice the output in terms of behavior. Can anyone tell me one small difference? I'll give a hint. Hint will be obviously a couple of words. And I'm putting the hint in the chat. This is the hint. Now can someone tell me the behavioral difference of the LOC method in Pandas versus the continuous indexing slices in NumPy? Nobody? It's including the last one. Wonderful. Great. So where were we? We were in this LOC business and I told you that slicing works. Okay. So for DF, if you see the labels are 0, 1, 2, 3, 4, 5, whatever, right? So this LOC is actually accessing the Pandas labels, not the NumPy labels. And of course, slicing still works. The only difference is that it is inclusive. Okay. So in tempdf, for example, if I have tempdf here, you can do slicing on both. So when I do A2 to A6, I will get this till A6, right? And for column, I'm saying age to expenditure. So ideally, I should be getting 3 columns. So if you print this, you will get A2 to A6, 3 columns. Okay. Right. So you can do the same with the DF data frame also. I think this stuff is pretty obvious at this point. So notice that the LOC indexer is slightly different from NumPy. It is inclusive of the end position. Okay. Everything else is the same. So for example, if you do A4 colon, this means what? This means from A4 till the end. And if you do colon cuisine, this means everything from the start to cuisine. So this is what? Tempdf. So you can print that separately. It should give me A4 to A10. It should give me name age cuisine, right? It should give me name age cuisine. So here A4 to A10, name age cuisine. And what is this going to do for DF? Again, you print DF and see what's happening. That's 3 is Mr. Ahmad here. So from 3 it goes to 9, right? 3 to end. And then for cuisine, it is from beginning to cuisine. So it will go from room to cuisine in this case. So now you have room to cuisine, 3 to 9. Okay. So the indexing and slicing operations are quite similar to NumPy arrays, but not exactly the same in LOC. Okay. Fine. Now let's quickly sort the quizzes out and then after that I'll launch the end poll, and then we can close the session. And again, just a reiteration, guys, please do give your feedback each time. It is valuable. Okay, quizzes please. Okay, just use LOC. Okay, which car's information is stored in 78th row of DF cars? Just use LOC. Don't even see the data frame. I don't even what are the index? I mean, at least to understand the index, you should print the data frame one. So here I can see it is integer index. So now df.loc what 78? Yeah, 78. Okay, I have a small doubt here. Okay, I have a small doubt. So let me just print df cars. Okay. Yeah. Can everyone see this Alfa Romero Quadrifoglio? I have highlighted this car, Alfa Romero Quadrifoglio. Please say yes if you can see what I've highlighted here. Would you say this is the second row of the data frame or the third row of the data frame? Third. Rajat says third. Sri Prakash says third. Abhishek says second. Parul says second. Right. This is where the language starts getting a little dicey. But see, most people are saying third row. Let's be honest here. Most people are saying third row. So for third row, the LOC should be 2. For the third row, LOC should be 2. Then if I say find 78th row, yeah, df cars.loc 77.car name. Okay, Mitsubishi Lancer. If I had said row named 78 or row number 78, then you will get the 79th row. But in English, if I'm saying get 78th row, yeah. So this is a distinction that we should all be careful about. Okay, distinction we should all be careful about. I'm not saying there's any exact right answer here, guys. I'm saying most people, if I say get the third row, you're getting with LOC2, not LOC3. Okay, that's all I'm saying. Okay, great, nice. What about the next quiz? What rating did Indira give to the movie Annabelle in DF movies? Can we extract this value, please? Give me the command. Indira has rated Annabelle something. What is that value? What is the command? Use LOC. Yeah, perfect. DF movies, Indra Annabelle. That's all. So that's how simple LOC is, and that's how it is for me, right? The kind of analysis that I've seen, I've done for data analysis purposes. It's important to have proper names. Okay, it's not necessary. It's important. Okay, it's easier. So I'm just copying one of the things here. df.loc Indra Annabelle. That is 6. Right. Now I think somebody had asked the question: if I have 1,000 rows, I have so big data, what to do in that case? See, I think it was Sonal, right? See, now we understand the methods. Do I even need to look at the data frame anymore? No. Okay. If I understand the methods, if I understand the data frame, that's enough for me. So I have told get the rating of Indira for Annabelle. Tuck LOC Indira Annabelle. Perfect. I didn't even see the data frame. Right. So this is my point. We train ourselves in all these things. Then when you see 100 columns, 1,000 rows, it really doesn't matter.
If you're learning to code, you probably want to master the tech world. Join our job-linked Data Science and AI Advanced Bootcamp program at upGrad and gain the skills employers are looking for. With a practical, industry-focused curriculum and hands-on projects, you will learn from seasoned experts and apply your knowledge to real-world problems. Don't miss out. Click the link in the description to start your data science journey today.
Okay, so what I'm going to do now is, so what we've been doing in the past is we've been running cells so that we can continue where we left off. But I think now we have developed enough familiarity with, these things that we know exactly which line of code we need. So let's start from that, right? let's what we need is we need df, we need temp df, we need what's the df movies, and we need df cars. So what you can do is you can actually just go up and select the required read commands, right? And we'll only execute those. And of course we need to execute this import pandas, and we don't necessarily need import numpy, I think. If required we'll import, but I don't think we need it for this session. We need, of course, df, which is our, what was it, the buffet details, right? So you can find that in reading data frames, right? So the last one, this one, yeah. So this is df, and if I remember correctly, temp df is nothing but the same buffet details with the index column set to room, right? So I'm just collecting the commands that I need so that I don't need to run everything before that, So I need this, and then I need tempdf equal to this with index column equal to, what was that, room, and I need df cars, that's pd.read csv, and I think it's car prices.csv. In this we did not set the index column, I think. So, and then df movies is pd.read csv. What was that, user with a capital U. So yeah, and in this we set this to user, right? So these are the 4 commands we need, I think, mostly. If we need something else, we'll check it out later. And we need import pandas as pd, okay, which I already executed in the beginning, that line. So now I can execute all of these, and these are all ready. So can we do this? Have we done this? Let me know in the chat. Okay, and always test your outputs. So does df look the way it's supposed to look? It's the buffet details with the integer indexes. Okay, then temp df is the buffet details with room indices. Then df cars is the cars data set with integer indices. And then df movies is the movies data set with user indices. Okay, always check that. So in the last lecture we ended with LOC, which was the pandas labeled index method of accessing elements from data frames, right? Both columns and rows have 2 types of indices. One is the numpy integer indexing, which is always there, and the other one is the named label indexing, which we can place. So LOC was the one which indexed based on the labels. Okay, right? For in this case, it was we saw I think movie names, user names, room number, and was expenditure, those kinds of things, column names, right? Let's move on and continue with iLoc, and this should not come as any kind of surprise. iLoc is just the integer indexer, right? So for this I'm going to use this df which is the buffet details with the integer indices here, which has been pushed forward because I did not specify any row index, and temp df, right? And this one in this case I have used room as the index for the rows. So LOC, for example, if I do df LOC, this we already studied, right? This is working, 0 is working because in df we did not label the rows, right? So if I do df LOC 0, I'm getting room A1, name Shilpa, so on and so forth. Same df iLoc 0, right? So iLoc is accessing the numpy integer index, which is behind this. So there's a 0 here. You can see this 0 here. This is the pandas 0. Behind that there is numpy 0, right? So iLoc 0 is going to give you the same row, but it is now using the integer indexing. Now if I do tempdf.locA1, we saw that this also works, right? So it's essentially from this data frame you're using LOC indexer and you're using this index here, A1, right? Now, if I do tempdf iloc a1, definitely I can expect an error, right? So I just ran this and it gives me type error, cannot index by location index with non-integer key, right? So iloc requires integer key. That's what the error is saying. Okay. So now if I do tempdf iloc 0, I will get Shilpa age 18, whatever, right? So the first row, and that means what in Python language, it's row number 0, or you can say row with index 0, right? Which is the first row. So if you want to extract the first row when you do not have, when you have, uh, in any case, even if you do have labeled index or you don't have labeled index, the integer index is always there. So in this case, if I do tempdf.iloc0, that is going to give me the first row, right? So similarly, you can get, iloc1, iloc2, whatever. So iloc indexer is strictly positional and it accepts only integer, that is whole number arguments. Okay, and in fact, the iloc indexer references the default indexing that is at the back end. This is the NumPy indexing, right? It is similar to LOC in terms of the argument structure and all, but obviously there are differences which we are able to see now. Okay. Now, as usual, if you want more than one, if you want to access row and column, then you need to give a tuple. So for example, if I do df.iloc, and let me just print df here, right? So iloc 0, 1, 0, the first one refers to the row. So here, obviously, I can use this one, iloc, in any data frame I can use, by the way. So it's the first row, and 1 means what? 1 means this column, second column. So 0 is the first column, room, in this data frame, and 1 is the second column, that is name. So df iloc 01 should give me Shilpa, right? So 0 is the first row, and then column number 1 means second column, right? This is the element I got. Right now, tempdf, in tempdf, if you see the 0 index here for iloc will again, it will index the first row, right? And 1 in this case will index the age because room has gone into the index. So now the first column is name and the second column is age. So 1 here will refer to the age column. So if I do tempdf iloc 0, 1, I should get 18. Okay, here I can get 18. Right. So again, all the same rules apply. The only difference, for example, here if I show you df.iloc 0 to 5, right? So here let me print df, and in df it has 0, 1, 2, 3, 4, 5, right? Now if I take 0 to 5 and then the first column, that is, column with index 1, which is the second column, by the way, name. I told you that this language is going to be a little weird, and I think sooner or later our minds will be understanding this language better than the English that we are speaking. Okay, so df.iloc 0 to 5, 1, it's going to give me name and it's going to give me what? That's the only thing that we need to see, right? Now in this case, it does not include 5. Why it does not include 5? Because this is based on NumPy indexing, right? So you are using iloc, which is strictly based on NumPy indexing. So you're using the integer index on the backend. Okay. So here when you do 0 to 5, 5 is exclusive, which is why you got Shilpa, Jaspreet, Dominic, Ahmed, Joseph, 0 to 4. Okay. And this 1 gave you the column, second column. All the other things remain the same, right? You can slice, you can do lists, all that you can do. So if I do 0 to 5, 1 to 3, what will happen? 5 is excluded, 3 is excluded. So I will get 0, 1, 2, 3. I will get name and age, and I will get 0 to 4. So I got name and age for 0 to 4. Okay. So note that the iloc indexer is closer to the indexing behavior when accessing elements from NumPy arrays. The reason that it's closer, it's because it's exactly built on top of that, right? It is exclusive of the end position. It is almost exactly the same as NumPy. And here, whatever you could do with NumPy array indexing, you can do using iloc for data frames. So you can even do things like this, right? So if you want row 0 to 7 and you want column 0 to 3, and what does that mean for df? What does that mean? 0 to 7 is what? Shilpa, Dominic, Preeti, and 0 to 3 column means what? Room, age, cuisine, I think, right? So let's print and see. Room, age, cuisine, and 0 to 7, right? These guys. Yeah, everything is clear. Let me know in the chat if everyone is in the zone. We are all on the same page. We are all in the zone now. Wonderful. Great. So great. Move on to the quizzes, right? There's no complication or magic here. We know LOC, we know iLoc. You know, we've gone through the hard work of NumPy. So Pandas should be easier. Yeah. Okay. Which car's information is stored in the 78th row of DF cars data frame? Use iLoc. Give me the command. Remember, 78th in English language means what in Python language. Okay. So, and sure, you can try printing the data frame, but try like challenge yourself that without printing the data frame, can you just imagine and get the command? Okay. But yeah, typically it's okay to print and study the data frame. It's fine. Just an additional challenge. Y comma 2. What are we getting, Ashish? Let me see. Ashish says comma 2. Oh, name. All right. Nice. Good. Yeah. Wonderful. That is right. So I mean, yeah, that's a really specific answer, Ashish. Therian, your answer is also correct. No problem. Your iLoc is correct. Ashish, your answer is more specific, which I think, yeah, that's quite interesting. So I think that's much more pinpoint answer, right, to the question. Which car's information is stored here? So now you're telling to someone which car's information is there, you know, then to the point, if I have to say, then yes, iLoc 77,2. Correct. So yeah, this may be a bit hard if you do not print and study the data frame. And by the way, you can just print the data frame. I usually just print head 2 so that it does not occupy too much space. Then you can see actually, you know, what columns are there. And car name is obviously 0, 1, 2, which is why 2 is here. And 78th row means we are using iLoc 77. So the integer column index is 8 for Annabelle. And then count again from 0 here. 0, 1, 2, 3, 4, 5, 6, 7, 8. Start from 0. So I think it is DF iLoc 88. Yeah. DF movies iLoc 88. Yeah. Okay. Right. You have to do the counting. And there's a reason that we are doing these quizzes. First, let's solve the quizzes. Then I'll talk about it. Right. Next, what ratings did Manish and Ravi give to the movies Thor? Same question, but use iLoc. Please give me the command. Again, remember the integer index exists, but we can't see it if we have given labels. And both row and column starts with 0. Okay, we have one answer here. DF movies, Manish and Ravi. I'm only seeing one here, 112. So that seems to be Manish, I think. I don't know. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's Manish. Okay, we are somewhere there. Manish and Ravi. So Ravi, if Manish is 12, then 13, 14, 15, 16, 17. Ravi is 17. Okay, so I need to put this in another list. And here, because 0, 1, 2 is contiguous, you can also do 0 to 3 like this. Now you'll see Manish and Ravi for Thor, Justice League and Spider-Man. Yeah. You can do list also, you can do slicing also, Ashish. Yeah. Okay, so the reason why we went through this exercise. So when you have much larger data frames, okay, iLoc becomes a little tedious to use. So this whole exercise, right, LOC we did yesterday, iLoc we are doing today. Ideally, we should do both in one day so that we get the comparison properly, but it's fine. We remember LOC. So, yeah, that's correct, Akash. Akash is correct. You can also use integer index. Sorry, what am I saying? You can also use continuous indexing, right? So 0, 1, 2 is continuous. You can do 0 to 3 also. Yeah? That also is correct. So the point is, when the data frame is very large, iLoc becomes extremely tedious to use. Okay. Which is why we usually, when we do data analysis, it's typically a good practice to give some unique column which has like unique identifier as the index. So in the buffet details data frame, I gave a column called room. Room has to be unique, right? So in one data table, how much did the person or persons in one room, how much did they spend? on the hotel buffet or whatever. So I need a unique identifier there. So you see the decision making that you need to do. If you are not able to find a proper unique identifier for your row index, then you have to live with integer index. Okay, so that time 0, 1, 2, 3, 4 will be there. If you are able to find a good unique identifier for your row index, then you put that and you can use that. So LOC and iLOC both have their uses. Typically in analysis, it's easier if you do LOC for obvious reasons, right? iLOC becomes more technical, more abstract, more difficult to use. But in case you're doing things like automatic transformations and maybe loops and things like that, then that time you can think of using iLOC. Okay, the point of this was to show you the advantage and disadvantage, both LOC and iLOC, and of course we saw the direct access method also before. Okay, now having said that, there are some additional indexers which it's worth mentioning and worth exploring if later you can explore more. So we have a couple of indexers called at and iat. Okay, they are similar to LOC and iLOC. So what at does is so both of these give you one element basically. LOC and iLOC and the direct access method give you multiple elements if you want, right? At and iat will give you one element. So they are essentially single element querying operators. Okay. So at obviously is similar to LOC and iat is similar to iLOC. So for df, for example, if I take df, if I say which element is at 3 and expenditure. So 3 means this and expenditure is this. Therefore, I should get 19.54. Okay, so it extracts one element. Similarly, if I print tempdf say, and here I'm asking what is the preferred cuisine of the person or persons in room number A3, right? So that's what at does for you. So A3 and then cuisine. So that's Indian, right? I do this and I get Indian. Similarly, iat, these are integer indexers. So if you go back to df, what is iat 2, 3? That's 2 is here, 0, 1, 2, and then 0, 1, 2, 3 cuisine. This should be Indian, right? Okay. Similarly, tempdf iat 4, 3. So 4 is obviously not A4, and that's the point. That's the difference between iLOC LOC. This is not 4. 0, 1, 2, 3, 4. 4 is actually A5, and 3 you have to count again 0, 1, 2, 3. So cuisine of A5 Indian. That's what you're using the iat. Okay. Which, sorry, maybe it's the wrong data. 0, 1, 2, 3 is expenditure. Sorry. Yeah. So you start with 0 here. 0, 1, 2, 3. So third column with integer index 3 is expenditure, which is what I'm pulling out here. 3. If I wanted cuisine, I will do 2. Indian. Okay. So these things access single elements. They have its uses, of course. These are single query elements. You can, of course, do the same thing using LOC and iLOC. These are just more specified operators. Okay. Now, and since we are still discussing accessing, I'll show you other access methods. Now, LOC, direct access, iLOC. These are the most important major fundamental level access methods. Now I'm giving you examples of various different access methods which are typically used in different cases. So at iat, when you want single elements, sure, when you're doing very simple queries, you can do that. You can also access columns by data type. Very interesting. So if I just do, for example, df, and I check df d types. Okay. Let me check the data types. So room is object right now. Name is object. Cuisine is object. Age is integer, clearly integer, and expenditure is float. Okay. So now there's a inbuilt command for the data frame object called select d types. Okay. This also has its uses. Okay. So if you want to select only object type, then you can say df select d types include equal to object. Okay. So the basic parameter here is include, and if which is the first parameter. So if you know the parameter, you don't need to use it as long as you know that it's the first parameter. Okay. The parameter name is include. So select d types include equal to object. So if I do that, it will not give me age and expenditure. So it is only giving me subset of the data frame where the columns are object data type. So here you can see these are all object. Okay. I can also use this command to get integers and floats and things like that. So if I do df select d types integer, this gives me the integer features in my data set. Float, if you do, you will get float features in your data set, and so on. So basically you can access columns or features based on the data types also, and you can explore this further on your own. Okay, I've given you some examples here. You're free to explore more. Now we've done this in NumPy, I think, right? Conditional access, which is also called Boolean indexing. We did a similar exercise in series also, I think. So this is very common, right? Because most of data analysis involves conditional analysis, right? Whose expenditure is more than so much, or which factory units profit is less than certain value, right? So conditional indexing becomes very important, which of course is transported from NumPy, put into series, transported from series, put into DataFrame. So everything is coming from your NumPy access only. So suppose I have DF, and these are in dollars, by the way, the expenditure, and I can ask the question, where is my data frame's expenditure greater than 15? Now see the syntax for this. Okay, DF bracket expenditure greater than 15. Okay, so you're basically querying using the column. So if you print this, you will get, what is the output? What's the output here? It's a series. Okay, so DF column, this itself is a series. Okay, this is a series. We know that every column is a Pandas series. That greater than 15. So then it gives you an output series with the row indices 0, 1, 2, 3. These are your row indices. So wherever the expenditure is greater than 15, it will be true. Wherever it is less than or equal to 15, it will be false. Okay. So now you can use this Boolean series to subset your data frame, right? So this whole Boolean condition, this output series, you can directly put it inside your data frame using the basic direct access method, that is square brackets, right? So if I just do this, it will give me the subset of the data frame where this condition is true. Okay, so note that. So what are the things to remember here? This is a series, it's a Boolean series. You're with the row indexes matching with the actual data frame row indices 0, 1, 2, 3, 4. So for all the rows, it is going to give me true, false for the condition that you put here. Now this series you can use to direct access from the data frame. So here df bracket df expenditure greater than 15. So then it gives me the subset of the data frame where the expenditure is greater than 15. It also gives me all the other information. Okay, if you only wanted the column, then treat it as a series, right? So instead of df bracket df expenditure, you can just put df expenditure then df expenditure, like this, right? I hope that made sense. So this part is now already the subset of the data frame, which is a series, right? And and this output is a series. This output series you are now again indexing using the Boolean output, true, false, true, false, true, false. Okay. So if you want the full data frame, use the logical condition within direct access method of df. If you want only a subset, then you can actually specify that subset here. So here I can also do expenditure, comma, room, whatever. So now it is going to give me expenditure and room wherever expenditure is greater than 15. Okay. So here I'm using a combination of operations. I'm doing subset access plus conditional access. Okay. So as I told you yesterday, just keep in mind what are the outputs, and then it will be easier to understand this. Now we can even put conditions together, right? So df expenditure greater than 15, I have these, right? And already I think this should start making sense, why I should actually label my indices, because right now it is 0, 1, 2, 3, 4, and it says 0 true, 1 true, 3 true. So what information am I getting from this? I'm just getting that the row, the first row of my data frame, whoever it is, expenditure is greater than 15. The second row of my data frame, whoever it is, expenditure greater than 15. So if you want to increase the richness of the information, we should always set the row index as proper labels. Okay, in this case, room is a good example. Anyway, let us first do with df. Okay, so this is one series. Now we can also use other logical conditions. So suppose I want to know cuisine, and I want to know which of the observations in my data frame have spent money on Indian cuisine, right? Their preferred cuisine is Indian cuisine. So I'll say df bracket cuisine. So what is this actually? This is a series, isn't it? This is actually a series output. So this series output, now you're checking whether it is equal to Indian. Okay, so here you're going to get wherever it's Indian true, wherever not Indian false. Now this condition and this condition, you can put it together. Okay, so if you want both to be true, then you will put and. So here you can see and. If you want either or condition, you can see here there is a or. So for or, we will use this straight slash operator, right? Shift and then backslash. So you'll get the straight slash operator. For and, we know we will be using the and operator. So now if I take these two series and do a AND operation between them, then true and true will be true, false and false will be false, true and false will be false. So wherever both are true, it will be true. So you can check that output. So you get true, false, true, false. So if you see here, true and true is true, true and false is false, and so on. Okay. So now you can use this complete logical condition to subset your data frame. So take this whole logical condition, right? Take this whole logical condition and use it as direct subset from the data frame. Okay. So now you will get wherever expenditure is greater than 15 and cuisine is Indian. So what is this subset really? Who of my customers in the hotel are spending a lot of money on Indian food? Basically, this is the answer to that question, right? Now I can even do more on top of this. Now I have the full data frame and I want to answer the question, give me the room numbers of the people in my hotel who are spending a lot of money on Indian food. Then I will do something. Then as hotel manager, I can provide to those rooms additional pamphlets of more Indian food, isn't it? So this is where data analysis is used. Okay, hope it's becoming clear. So if I just do df whatever, this whole condition and then room, I'll get A1, A3, A5. Now I'll just take this list and tell to my the management services in the hotel, you know what, these rooms, I think they really like Indian food. They're spending a lot. Just can we come up with a quick pamphlet of our new Indian delicacies, and we'll just give the pamphlet to these rooms, right? It's becoming clear, yeah? Data analysis, how useful it is, right? So another thing is that you don't need to put this at the end. As I told you, you can subset first, then you can put the condition, or you can put the condition first, subset, then you can take the subset, right? All that you can do. All right. So what does this command tell you? This command tells you that you can do the data frame subsetting with the conditional access first. Output is a data frame. And obviously, if the output is a data frame, you can do whatever you want with the data frame, like accessing, LOC, everything you can do, right? Because this output is a data frame. Now, what do I want from this conditional data frame? I want the room number. So this whole thing, how do we read it? It says subset my original data frame use and keep all the columns wherever expenditure is greater than 15 and cuisine is Indian. And then from the data frame, give me the room column. That's how you read this. And that's what it is doing. Now the interesting thing is what? That you can actually subset the data frame first and then you can put the logical condition. So for example, here I've shown you, see, this is the same logical condition with the square bracket access method, right? So I'll not remove it. I'll remove this and I'll print df room. Now you will say this is a series, correct? This is a series. Now this is my logical access condition, isn't it? This is my logical access condition. Let me just remove the square brackets that I can print it. So this is my logical series. Now I have done basics of Pandas series before. We have done this before, right? You can access the original series if your indices match and you have the true false logical values of that series based on some condition. So since df room is a series and I have my series output for the same row indices 0, 1, 2, 3, 4, 5, 6, 7. These two are the exact same series in terms of keys, right? Index or key, what do you want to call, they are the same, right? Because they come from the same data frame. So now this logical condition can be used to access or to subset from this series, df room. So df room is all the rooms series, right? and then you can access this using the logical condition, which is expenditure greater than 15 and cuisine equal to India. So you might be thinking expenditure cuisine don't exist. Well, it exists for DF. It exists for DF. So the object I'm using here to condition this is what? DF expenditure, which is what? DF. DF has all these columns. But the output is actually a series with the row indices. Getting clear now? So now you can go back and access the row indices where the output is true and false, it will not show. Now, once you access the row index, it depends on which object you are taking subset. If you're taking subset from data frame, it will show you all the columns of data frame. If you're taking subset from series, it will show you the values of the series where the condition is true. So what it has done is essentially subsetted the row indices. Okay. What it has done is subsetted the row indices. Then those row indices you can match. Either you can match with one column, which is a series, or you can match with the full data frame because it's the exact same row index. Okay, that is the thing that we are learning here. Okay, so for example, if I just do df bracket name, you can see the row index 0, 1, 2, 3, 4. This will become much clearer if you use temp df. So for example, let me actually use temp df for the next one. So here, let me use temp df. Okay. So let's say temp df, this is my room and whatnot. Now suppose here I do temp df bracket name. Okay, what is the index? A1, A2, A3. It is the actual row index from the data frame. So the subset series that you got is still matching with the same row index from the data frame. So now if I say something like temp df say expenditure, right? Temp df expenditure greater than 15. What is the output? True, 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 false, false, false. But what is the index? Index is still room from the original data frame. So all of these components are series from that same data frame. Now this logical output series, the Boolean series, true, false, true, false, true, false, it's essentially saying A1 true, A2 true, A3 true, A6 false, A7 false. Now this, if I use to access any other component from the original data frame, wherever it is true, it will give me output. Wherever it is false, it will not give me output. So for example, temp df name, if I now want to access, so I'm putting another square bracket, correct? This is a series. So square bracket for, calling out the index. Now here, if I say A1, it will give me Shilpa. If I do A2, this will give me Jasprit, correct? So I'm indexing using the keys. Now if I delete this and print again, it will give me the full series. So inside the square brackets, I can actually use the Boolean series. What will that give me? It will give me the subset of wherever it is true. So the index, row index, wherever it is true, that row index will match with the original. So here you see A1, A2, A3, A4, A5, A6, A7. So wherever this is true, that will be retained. So Shilpa will be retained. Whoever A6 is not retained, Saju is not retained. So now this logical condition, I can put it here. Shilpa, Jasprit, Dominic, Ahmed, Joseph. This thing works for the data frame also. So if I just remove this temp df name, which is a series, right? Now it's only a data frame. I removed the column. So now full data frame. I print it. I will get the subset of the data frame where this condition is true. You can use this for subsets, any subset of the data frame, including the data frame. I hope we remember set theory, set language from mathematics. Any subset of the original data frame means what? The data frame is a subset of the data frame. 2, 3 columns from the data frame is also a subset of the data frame. Any single column from the data frame is also a subset of the data frame. So when you do logical accessing, it directly goes to the row index, which is common for all of these subsets of the data frame, which is what I showed you. Is it clear, guys? Please put in the chat if it is clear. Any more doubts on this? No doubts? Okay, great. So now the OR condition, this is something, OR means what? OR means either or, okay? Either this is true or that is true. It's a loser condition, right? It's not a strict condition in analysis. But point is, you can, of course, combine logicals using OR also. So if you do expenditure greater than 15 or cuisine equal to Indian, then you can get the rooms where either the expenditure is high or the cuisine is Indian. Where is this useful? Maybe my hotel is efficient in creating Indian cuisine, so I'm saving money there. So probably I want to know who's uh, preferring Indian cuisine, so I can sell more Indian cuisine to them. Or if people are spending a lot on non-Indian cuisine, still, my cost of creating non-Indian cuisine may be higher, but if those rooms are spending more on those, I'm okay with that, right? So this is more of a loose condition. So basically the hotel manager might say, see, Indian cuisine, we are obviously creating a cheap rate, so definitely find out the rooms who are having Indian cuisine. Also, regardless of the cuisine, if the room is spending a lot, that means that they really prefer and they're ready to pay for the cuisine. So find out who are those rooms. Doesn't matter if they have Indian cuisine or any other cuisine, no problem. So this is a loser condition. So for this you will use OR. Okay, and I hope this access method is clear. Right. There's also some very interesting access methods like this one. So is in, okay, there is this dot is in method, which is a series method and a data frame method, of course. But for example, if I want to know whether which cuisine is either Indian or Chinese, so then I can do, for example, df cuisine dot is in, and that literally means is in. Okay, this cuisine is in this list or not. Okay, so df cuisine dot is in Indian Chinese. Now let me just print df to see what my cuisine is. Indian, American, Chinese. Okay, so df cuisine dot is in Indian Chinese. So obviously I should get, Shilpa, Jaspreet, Dominic, Ahmed. No, I shouldn't get Jaspreet. Sorry, Shilpa, Dominic, Joseph, Saju, Monica, so on. So everyone except American, right? If I do that, again you will get a series. Okay, so again it's showing whose cuisine or which row's cuisine column value is in this list. Okay, so is Indian in this list? Yes. Is American in this list? No. Okay, so like that. And I hope everybody is aware of this tilde operator. Can you put in the chat if we know what tilde means? This one, this operator here. No. Okay, it means not. Okay, tilde means not, so opposite. Tilde means not. Okay, opposite. So here, wherever true, false, true, false, true, false, it's going to switch. Complement. Yeah, it's basically the logical complement. So if you want to know who is not in Indian and Chinese, who is not having Indian Chinese cuisine, then you use not in front of the Boolean series. So not df cuisine is in Indian Chinese means American, by the way. So I should get true for this one, that is index 1, and I should get true for Ahmad. I should get true for Preeti. So I should get 1, 3, and 7. Let's see, right? So here true you will get at 1, 3, 7. Okay, so not is basically the complement operator, opposite. Okay, so obviously you can now use these series. Not in. Good question. You can check that. I don't remember whether not is in. You mean not is in? I don't think it's there. So the reason it's not there is probably because it's so simple to complement the series. I think, right? Check it out. Pandas not is in. I don't think so. No, is in operator is there, but not will not be there because it's simple. It's just not of the output series. And by the way, logical operations are the most easiest thing for a computer to do. Correct? 101010. So that probably there was no reason to build it because is in operator is there. So function is there, so you don't need the not is in function. What can we do with these Boolean series, guys? I just explained to you. You can do you can subset your data frame, then apply the Boolean series. You can apply the Boolean series on the data set, then subset the data set that you get, right? Chain the commands and see what's happening. Okay, by the way, just to clarify, I am chaining commands very easily because I have a lot of practice with these things and a lot of experience with these things. If you're feeling that you need to break it down into steps, please break it down into steps, get a feel for how it is working, then start chaining commands. Okay, so please feel free to learn that way. All right. Anyway, so this Boolean series, what can I do? Subset the data frame. That's all. So this is just, and by the way, I hope we know that this is not the only way to do. This is a more sort of user friendly, efficient way to do, but this is not the only way to get this series. Can someone tell me, is there any other way to do this? This one, DF cuisine is in, take this one for example. DF cuisine is in Indian Chinese. Is there another way to access and get the same output series? Anyone? Any guesses? It's okay. Feel free to answer. Or operator. Exactly. Yeah, equal to with or. Correct. So if I just do df cuisine equal to what? Indian, and then bracket, I have to put bracket, otherwise it will get ambiguous. Or df cuisine equal to Chinese. If you see, these two series are exactly the same. Okay. And of course, there's another method. Given you know all the different possible values of the cuisine variable, there is another method obviously, which is not American. Okay. For that, you need to know the the complete cuisine variable. If you do know the complete cuisine variable, then I can do not df cuisine equal to American, and that will also give me the exact same series. Okay. So hope all these logicals are making sense to you guys. Let's practice this. That's the best way to get a feel for it. How many cars in the DF cars data frame are sedans? Please feel free to print the data frame and study it. And please give me the command. What are sedans, by the way? I think that kind of car, no? Maruti Swift. And I don't know, is Ambassador a sedan? I don't know. Do we have any car enthusiasts, car experts in this audience? I'm just saying, I'm not really a car expert. Okay. So as far as I know, sedan is the car which has like this and then goes up and then back like this. Right? It goes like this, like this, like this, I think. Anyway, Abhishek says length. Okay. How many cars? Correct. Okay. Sauradeep, DF cars car body is in sedan. Correct. Question is length. So change the command. And here Abhishek says length DF cars car name sedan. I think this one will work. As you can see, guys, see sedans. So obviously this is where, you know, in data analysis, little bit of domain knowledge is required. So if I have absolutely no idea what is a sedan, then I have to sit and study this data frame for a long time. Then only I'll find out, okay, car body has something called sedan. Suppose your car body, you know, all the features, all the first, let's say 100 values of car body is convertible. So you don't even see sedan. Then what? So this is where we need data analysis is, you know, it separates from abstract mathematics. Abstract mathematics is different. Mathematics is different. Data analysis, we need to be in touch with the real world. We need to know what we are talking about really. So for example, I know for some reason, I don't know, but I know that sedan is something like this. It's a car type, as someone pointed out, type of car, right? Model, Abhishek said it's a type of car. So we need to know something about the data. Okay, that much is required. So studying the data, knowing what's in the data, little bit knowledge also will help to do much better data analysis. Okay. So DF cars, what is Abhishek's comment here? Len DF car sedan. Yeah. So in car body, I can see there is something called sedan. Once I find that much, it becomes obvious that I need to just do len DF cars car name equal to sedan. Answer is 205. Wow, there are 205. Let's quickly find the percentage. What? Our name, hey Abhishek, you made a mistake. That's why I was a little surprised here. 205, not possible, right? Not possible. And length also will not help you here, by the way. Length of a false series is also okay. So let's go back here. So here we have some series. For example, let's take this series. DF cuisine is in Indian, whatever, right? So here, if I just do length of the series, it will give me full length. It will give me all the length. 10. It will give me all the length, right? So what I need to do? Uh, what I need to do? I can't take the length of the Boolean series. I have to take the length of the subset data frame. Using the Boolean series, I have to subset my data frame, then I have to take the length. The Boolean series length is total 10. This is what I've been explaining till now. Whatever logical condition you apply, it will give the true false value for all the rows. So the length of that series is what? Equal to the length of the data frame. Right? Only when you use that Boolean series to subset your data frame, then only you will get the subset data frame. And from that I have to find length. So this is point number 1. Second point, car body is not the one I have to use. Sorry, I have used car name. I'm very confused. Okay, Abhishek has corrected. Okay, car body is the one I have to use. Yeah. So basically what I need to do, see guys, basically what I need to do, df cars, car body. This is the feature, car body equal to sedan. Okay. So now it will give me false true, false true, false true. Now I have to use this condition to subset my original data frame. Okay, what happened here? Boolean series key will be reindexed to match data frame index. Yeah, fine, whatever. Okay, df is wrong. Yeah, that's why I'm getting warning. Df cars. So df cars, car body equal to sedan. Now this gives me the subset, and in subset you can see 96 rows here. So now on this I can apply length. Yeah, this new one I think is the same. Yeah, this is correct. Equal to sedan. Answer is 96. Are we clear? So there are 96 cars in my data frame which have car body sedan. Okay. Next, let's try this one. How many users in the DF movies data frame rated more than 7 for Thor and Spider-Man both, but rated less 7 or less for Doolittle? Okay, these are all movies. So just print it. Take your time, guys, and give me the command for this one. This one. DF movies Thor, Spider-Man greater than 7. That's the only thing that looks suspicious. And the reason is ambiguity. Okay. See, Boolean logic is the most fundamental type of logic, most atomic type of logic. It's the Boolean logic works in 0, 1 bits. It's not capable. So Boolean logic is a very low level, right? Only the atomic bits. So when you have written Thor, Spider-Man greater than 7, how does DF movies know which one you are asking greater than 7? Is it both? Is it any one? We don't. DF movies does not know, right? So Boolean logic is a very atomic level logic. So you have to break that into 2 parts. Because of ambiguity, it does not know. Are you asking both 7? In that case, you should use AND. Are you asking what is that? Any one greater than 7? In that case, you should use OR. Correct? So this will give you error because Boolean logic cannot handle such complex things, right? So you're saying 2 things greater than 7. This syntax is not understood by Boolean logic. Okay, Akash has given a code. Let me check this one. DF movies. Okay, indexing using DF movies Thor greater than 7. Okay, and DF movies Spider-Man greater than 7. And DF movies Doolittle less than equal to 7. Yes, this should work. Let's check. So 6 people. So in my DF movies data frame, 6 users have rated more than 7 for Thor and Spider-Man, but rated 7 or less for Doolittle. Okay. Okay. So let's go to the next quiz, guys, and we'll do this without chaining commands. How many cars in the DF cars data frame are convertibles with a city mileage more than 20 and price less than 15,000. It has 3 conditions. Please look at the screen. I'm going to show this step by step. Those who want to do it quickly in one line, please go ahead. Others who want to see the logic, please see the screen. Okay. So now what I do is first I print my DF cars data frame, and how many cars are convertible. So convertible, the word is here. Okay, it's a type of car body. So that is one condition that I need. What is that one condition? DF cars are body equal to convertible. Okay, now this we all know the output is going to be series. I'm going to store this series with a name. I'm going to say car body convertible Boolean series. That's a very big name, so I'm just going to call it convertible Boolean. Okay, I'll save it here. Next, city mileage more than 20. Now where is the city mileage business? If you check the columns, you will find city mpg here. Another way to check the columns, dfcars.columns. Correct. Let's do this, and here you will see there is something called city mpg. Okay, let me print my dfcars again. So I have city mpg here. So what is saying? City mileage greater than 20. So now I need mileage boolean equal to df cars. What is the name of the column? City mpg. I can actually just copy from here, right? df cars city mpg. What? Greater than 20. What is this going to be? It's a series output, correct? So see, again it's a series output, boolean series with the row indices matching with the data frame. Okay, so here on the left side it's matching with the data frame. So this I will store it in mileage underscore boolean. Okay. Next, price less than 15,000. Go back to df cars, search your columns. There is something called price. So now price boolean equal to df cars price. Oh, sorry, df cars price. Yeah. What do I need? Less than 15,000. So this is again a Boolean series with true false for the row indices of the data frame. I'm storing in price Boolean. Now question says how many cars in the DF cars data frame are convertibles with city mileage more than 20 and price less than. So all 3 Boolean conditions should be true. So now I can create a final, let's call it final Boolean. Final Boolean series is nothing but convertible Boolean and where is and mileage boolean and price boolean. All 3 should be true. So now final boolean has been executed. We can check it. Obviously it is going to be a series. It is true false series, boolean series with row indices matching with the data frame. Correct. So this contains the information of all 3 logical conditions, right? Final boolean. What can I do now? I can just access my data frame using wrong data frame, df cars. I can just access my data frame using this final boolean. Only 2 cars, by the way. Only 2 cars are convertible with mileage greater than 20 and price less than 15,000. Those 2 cars are Alfa Romeo Giulia something and VW Dasher, whatever that is. I don't know the cars. Okay. Now if you want the length of this thing, what do you do? Just use the len method, which uses curved brackets. Okay. So len df cars with final boolean, that gives answer 2. Is it step by step clear now? Yeah, please try. Please try. I want everyone to. Thanks, Sonal. Others, I hope it is becoming clear this boolean. See, I was expecting that we can change the commands, but if it's becoming difficult, you use this. Do it step by step. And please solve the other also step by step. Okay, so as I said, if you are able to solve one of these, then definitely you can solve all of these, right? Okay, let's now move on to the next part, and let me just see, right? I have operations, then I have statistics, I think. Yeah, and then other data frame operations. Okay, let's do some basic arithmetic and data type operations. There is Tom here due to his network. Unfortunate. I understand though. So now we move on to standard operations. You can say standard operations in data frame. So we will study some important methods used to manipulate data in data frame. So changing the values and things like that. Okay. So we will look at some important methods, while briefly looking at some other important methods. So most important methods we'll go in detail. Other important methods which are maybe situational methods we will go through briefly. And I think there's a bit in the end which I feel is moderately important. So that's something that I might choose to leave it to you for self-study, which is at the end, because anyway we'll be using that in later topics. Okay. So as written here, as I'm saying here, you will work with all these methods throughout your data science journey, learning journey and beyond. Okay. Right. So we'll start with example 1, working with data types. So we already know this, right? Print your df, you saw your data frame here, print df.dtypes, you will get object int, whatever. So the thing is, you can convert data types very easily in Pandas. So for example, if I take df expenditure, right now it is float. The way to convert it to some other data type is this method here, dot as type. So it will take that series and then convert the data type of the series. So if I just do df expenditure, which is right now float 64, right, float data, I will do dot as type integer. If I do that, you can see now all my float values are gone and it has been rounded to integers. Here you see 24.65, 18.54, 27.66, so on and so forth, right? So here dot as type integer. Okay. So now if you check your original data frame, no change. Why there is no change? It is not in place. Akash, excellent question, right? It is not in place. Okay, definitely not in place, right? The original data frame has not changed. Okay. So if you want to do in place, you should overwrite the column. Okay. So if you really want to do in place, which I don't want to do here, the command that I'm not going to execute this command, but if you want to do in place, this is what you should do. Df expenditure equal to. So you're basically rewriting the series, isn't it? Right? This new series you are putting in the place of the old series. Where is this old series? This old series is part of df. Okay. So this is one method that you can do. But typically, if you want to do, some changing data types and things like that, you might sort of do for some columns. There is okay. For example, before going to that method, I'll show you some other things. So suppose df age, if I do as type int, obviously this is not going to do anything because age is already integer, right? So this won't do anything. Now here it says dtype int 32. The thing is, I can convert up. So if I do df age dot as type object, now age is object data type. These 1832, all of this object. In fact, I can even convert it to string. So df dot as type string. Now age, it says object, but what is object here? The Pandas series is object. So now if I just pull out the first element, which is 18, you can see it is a string. How did I pull out the first element, guys? I just used indexing method. How did I know that I can use indexing? Output is a series. Since the output of this thing is a series, I can use indexing. Okay, that gave me 18. So this is one way to convert the data types. Okay, all of these are not in place. Now there is a very interesting method which is you can use in most cases, but you should be careful sometimes, which is called convert d types. What it does is it converts the data types of the column series in your data frame to what Python believes is the best data type for the series. So right now, if you see df.dtypes, room is object, name is object, cuisine is object. So if you do convert d types, if you just do like data frame dot convert d types and assign it to the new data frame, okay, don't override the old one, assign to new data type. Now if you see the data types of the new data frame, now you get very clean. Room is a string data type, name is a string, cuisine is string, age is in 64, expenditure flow 64. So Uh, Convert d types is a nice method which correctly assigns, the data type which is best for that series. The only thing is that sometimes maybe you don't want that. Typically, it's okay to do that, but you need to take judgment calls. Do I really want this thing to be, a string? Do I want it to be an integer? So on and so forth. So use it, but always check the output. If you are satisfied with the output, then take the new data types. Okay. So as I say here, converting data type as per suggestion from Panda is generally fine. Okay, these are universal libraries, NumPy, Panda. Typically, the methods are well thought out, but there may be some cases, very rare cases, where you may need to check. Okay, do I want this conversion or not? All right, so we'll continue with some important operations, okay, with data frames. So example 2, arithmetic and intercolumn operations. These are quite similar because they are essentially series to series, you know, inter-series operations, which you've already done one before, right? In the series method, we did this prepaid amount and bill amount, right? And we found the, series comparison. So it's actually comparing two series. So they're quite similar. So suppose I take my DF. This is my what do you call it? The buffet details, right? And suppose I want to add 10 to my expenditure values. Now remember, this is very similar to the NumPy array operations. These are broadcast operations, right? So if I do DF expenditure plus 10, what's it going to do? It's going to add 10 to all of the expenditure values. Okay, so DF expenditure plus 10, 24.65 plus 10, 34.65, 18.54 plus 10 is 28.54, so on. So basically the same broadcasting operations from NumPy, right? So the same thing you can apply to DF expenditure. Suppose I want to do -5, and obviously these are not in place. Okay, these are not in place. So if you print DF again, your original values will be there. 24.65, 18.54, so on. Okay. So suppose I want to subtract, I can do -5 from expenditure. So now I have 19, 13, 12, 14. It is all -5. 24 -5, 18 -5, so on and so forth. Similarly, I can do multiplication also. DF expenditure times 2. Okay, whatever my DF values are, 24, 18, 27 into 2. Right. So these are all multiplied by 2. I can do division, for example. So DF expenditure divided by 3. Again, it's 24, 18, 27, all of these. And you're dividing by 3, 8, 6, 9, 6.5, whatever. What are the things to note? 1, output is series. 2, broadcast operations from NumPy arrays. Okay. So you can manipulate data columns like this. Age, if you want to say plus 10, DF age plus 10, 28, 42, 29. Age into 2, 36, 64, 38. Original age is, if you want to see, you can see it here. 18, 32, whatever, right? So plus 10 gives me 28, 42. Multiplying gives me 36, 64, 38, right? And so on. So obviously here we are using the basic Python operators. So these are all Python arithmetic operator syntax. Pandas also gives you its own functions, right? So if you want to add 5 to all the age elements, you can do dot add 5, right? So this is adding here. Now, as I told you before, Pandas, most methods will be having in place parameter, but some of these methods will not have. Okay, for example, this add, if I'm not wrong, it does not have an in place parameter. So the only way to replace the age with the new age column is you have to replace the series itself in the Pandas data frame. I'll show you how to do that. So you have a function called add, which adds the number here, and then you have a function called subtract, which subtracts the number from the age. Then you have dot mul, which multiplies the age by this number. You have dot div, which divides the age by the number, and so on. So typically we use the Python operations because they are just simpler. I think we are used to it, but Pandas offers its own inbuilt functions. Okay, so many of these inbuilt functions will match the Python basic arithmetic operations. Where it will not match is the more advanced statistical functions like mean, median, mode, and all these other things. Okay. So that's basic arithmetic operations for you. Now, if I want to do, inter-column operations, and why did I put these two things together in the same example? Because they are inter-series operations in a sense. So when you're doing df expenditure minus 5, what's happening is you have a series filled with the values 5 and the same index as this series, right? So this series minus this series is exactly what is happening, right? 24.65 minus 5, 18.54 minus 5, and so on. So we can also do inter-column operations because they are also series with the same indices, with the same row indices. That is why you can do these operations. So suppose I want to add the expenditure and the age, okay, which probably doesn't have too much real meaning, but just to show how to add two columns, df age plus df expenditure. If I do this, I will get a new series. This is a new series. Okay, so this is 24.65 plus 18, which is here 42.65, 18.54 plus 32, 50.54, and so on. So what you're learning here is that with the same indices, if you have different values, you can add them, subtract them, divide them. Similar to what we did in NumPy, the same thing is being used here. Okay. So, and this works not only for integer, float, numbers, it will work for strings also. So for example, name is a string, cuisine is a string, correct? So if I add two strings using Python plus operator, what happens? It concatenates the string, correct? So this is the name, which is string, cuisine is also string. What will happen if I do df name plus df cuisine? As you can see, it produces a new series. It concatenates the element. So what's happening is element wise, Python is checking what should be the output be. So int plus float number, int plus int number, string plus string number. So element wise operations with matching series, matching index. Okay, that is what is going on here. And of course you can do bit clean operations. You can also add a blank. For example, if I add a blank here, so df name plus a white space character in string plus cuisine. So then I will get Shilpa space Indian, Jaspreet space American, Dominic space Indian, and so on. Okay. So, and one other example we'll discuss before we go on to generalizing some of these statistical things. So we have seen the round method, I think, from NumPy. It's the same thing that is here. Okay, df dot round. So if I just do df dot round, what happens? Notice round does not do anything to the string elements. Okay, obviously. So pandas knows which function is applicable to which data type, basically. So if I do df dot round, I am actually applying round on every element in the data frame. Okay, but it will not produce any change in the string ones because round does not change the string values, but it will definitely change the integer and the float values. It is applying round on all of these values. Okay. Now, typically, this is not the way we use these functions. We identify columns which need, to be applied certain function. Then we will apply it. Then we'll maybe create a new data frame or replace the old data frame. This is typically not the way. You don't take a data frame and do dot round. It doesn't make sense. Your data frame has multiple type of columns, multiple type of features and data types. Okay. So you need to know your data frame. Then you need to manipulate the data. Okay. So for in this case, I can do, for example, df expenditure dot round. That makes more sense, right? And then I can assign this new series. I can just replace the original column with this. Okay. Of course, you can also round it to various decimals. You check the parameter here. If I want one decimal place, I put round 1 and then I get 1. I can put 2, it will round to 2 places, so on and so forth. Okay. Now, what I want to point out is that the rounding operation that I'm showing you here is actually the application of a function on the elements of the data frame. Okay. We will explore this a little more detail later because this is going to become important. What kind of functions do we need for string? What kind of functions do we need for integers, floats, those kinds of things. Okay. So here what I'm going to do is I'm going to solve quiz number 1. Okay, step by step. And then I want everyone to solve quiz number 3. Quiz number 2 and quiz number 4, I'm going to leave it for you guys to try out later. Okay. So these are a bit more, there are more operations that we need to do, right? So let's look at this. Find the mean of the city mileage and the highway mileage of each car, and please watch the screen. Let me solve this. Okay, then you try to solve quiz 3. Okay, so here what is saying, find the mean of the city mileage and highway mileage of each car in the df cars data frame. Add this value as a new column. Add this value as a new column to the existing data frame with a new feature name average mpg. Print the subset of the data frame, the new data frame, with the car name, city mileage, highway mileage, average mileage. Okay. So let me take this step by step. So first I'm going to check my df cars data frame, and it's saying I need the mean, that is the average of the city and highway mileage. So I know that there is something called city mpg and highway mpg, right? So I need df cars city mpg plus df cars, and I can just copy the name from here, highway mpg. So if I just do this, it will give me summation. Okay, it is giving me the summation of the city mpg, highway mpg. Question is saying find the mean. So what do I need to do? I just need to divide this by 2. That's all. So put the bracket and divide by 2. Now I have the mean of these two values, city mpg and highway mpg, for all my cars. Okay, so this is step number 1. Step number 1, let me just I have this output. Now it is saying add this value as a new column to the existing data frame with feature name average mpg. Now adding and deleting columns, there is a section at the end of the data frame which I propose that you guys should try to learn that and practice that on your own. I'll give you one instance here. Okay, so here I'm going to say df cars bracket, and I'm going to give the new column name here. That's all. So avg mpg, this is the new column name. So notice that this is a series. We all agree. Do we all agree? Please tell me in the chat that the highlighted part is a series. We all agree. Okay. Do we all also agree that the series has the exact same row indices as my original data frame df cars? We agree. Wonderful. So now df cars direct access average mpg is actually now going to create a column with the exact row indices of the original data frame, and therefore the series which has the mean data will directly map row to row to row to row to row, and there will be a column, new column. Okay, so let me show that df cars average mpg equal to df cars city mpg plus df cars highway mpg divided by 2. Execute this, and now if I just print df cars, and before I print df cars, I'll show you the columns. Can you see here average mpg in df cars.columns? So I have changed my data frame, and I think this is the first time in the complete pandas workbook we are changing our data frame, isn't it? This is the first time we are changing our data frame. Yeah, so notice that when you change your data frame, you should be very careful. Okay, you should not lose your original data, and you should be quite clear why are you doing this, and so you should be careful when you change your original. Okay, so and that's what I add this value to the existing data frame. That is what I've done here. Okay, so as you can see, average mpg column exists. So now if I just print df cars, and ideally what happens typically is that the new column always goes to the last. Okay, so there's average mpg, which is essentially the average of these two. So 21 plus 27, 48, divide by 2, 24. 19 plus 26, what is that, 45, divide by 2, 22.5. 24 plus 30, 54, divide by 2, 27. Okay, no Akash, it will not change the data in the csv file. No, when you close this notebook, everything is forgotten. So you need to save. So there is pd.tocsv. Okay, so those who are interested, I'm not going to get into this right now, but pd.to, so csv, just search for pd.tocsv. I think it's not pandas function, it's an attribute, as in it's an inbuilt function. So df.tocsv, I believe that is how it is. But pandas, if you check the documentation, it will say pandas.dataframe.tocsv. I think this is the way. Check the chat, I'm giving you the things, right? So if you Google it, this is the way that you will find the name of the function tocsv. So that will save as a csv file. Yeah. Okay. Don't do that right now. Please explore that on your own later. Okay. So now I want everyone. So quiz 2 and quiz 4 I'm leaving for you guys to do later. Quiz 2 may be slightly complicated. Think about it. Do it later. Quiz number 4 doesn't seem that complicated. You can do it later. But let's do quiz number 3 right now. Okay. So I'll explain quiz number 3 steps. Let's do it. Each car in the DF cars data frame also has spatial dimensions associated with it, namely car length, car width, car height. So basically this is inches, height of car, width of car, and length of car. Okay. And there is something called curb weight, which is essentially the weight of the car in I think this is not an Indian day set, so the weight will be in pounds or something. There is curb weight. Okay, see, you cannot see all the data, which is why you should subset sometimes. Okay, so here I want what? Car length, car width, car height, and curb weight. Okay, yeah. So this is in inches, and this I think it is in pounds, which is I think it's a measure for weight. Okay, whatever. This is the weight of the car. Curb weight is the weight of the car, and these are the spatial dimensions. Assume that all the cars are cuboidal. Okay, I know it's a funny assumption, but assume that it's all cuboidal. Okay, and then calculate the density. So do we remember formula of density? Anyone? What's the formula for density? F by A. I don't know what F by A is. Force by acceleration. So density is mass over volume. Yeah, density is mass over volume. Correct. Okay. Do we remember the formula for the volume of a cuboid? Mass over volume is correct. LBH. Yeah. Okay. So can you guys create a new feature in the original data frame under the name density? It is similar to quiz 1, what we did. Can we do this? Okay, please go ahead and do this. And after that, print the subset with the car name, car weight, spatial dimensions, and density. Okay. First, let's do the column. Okay. Right. So volume is L into B into H. Density is mass by volume. All the required columns are there. Car length is there, width is there, height is there, weight is there. Okay. It's called curb weight. And we are assuming cuboid. Okay. So this code looks messy, but it's easier because it's in one line. If you don't like this one line getting messy, then it's perfectly fine. So you just do something like car length equal to df underscore cars car length, then what is that? Car width equal to df underscore cars for car width, then car height equal to df underscore cars car height. So now I have 3 series, right? These are 3 series with my spatial dimensions. So now car volume equal to car length star car width car height. Okay. So can you all tell me what is this variable CARVOL? Do we all agree that this is going to be a series? Car wall, the one that I have defined here. First of all, do we agree car length is a series? AF cars car length, this one. Yeah, that's a series. Now I have multiplied 3 series together. Do we expect the result to be a series, Pandas series? Let's check that. Yes, it is a Pandas series. Okay. So this is my point. Inter-series operations will give you series. Boolean on series will give you series, right? And where is the series coming from? Each column of the data frame is a series. Okay. So obviously car volume is a series. Now because it's a series, then so what? So now if I say car weight, let's say WGT car weight equal to DF cars, and what is it called? Curb weight. Okay. Now we all agree car weight is a series. CAR WGT is a series. Car weight is a series, right? Car volume also, it's a series. Yeah. So what is series divided by series? That's also series, right? So if I just do, for example, car WDT divided by car VOL, output is a series. That's all. So this series you now have to provide to a new column. So df cars and column name is density. So density equal to this series here. So now it's going to produce a series and store it in the original data frame. Does it say here to change the original data frame? Yes, change the original data frame. So if I do this, and then now if I check df cars columns dot column, in the end you will see something called density. And if I just print df cars, at the end you will see density. Okay. So all of this can be done in one command like this. Instead of all this, you can do in one command like this. Okay. So just do that. If you do that, it overrides the original series, by the way. So because I did this series already exists, but again I can overwrite it, no problem. And finally it says print the name, weight, spatial dimension and car density. So df cars, I think car name was 1. Then what do you want? Car weight. So curb weight, spatial dimensions are here. Just copy paste from here to here. Right? Car length, car width. Use that should be a comma. Car height, and then the density. Right? Volume car is equal to. Explain once more. Yeah, Ankita. So just to summarize the steps, what the question is saying is that look, your df cars data frame, it has 3 columns called car length, car width and car height, which are the spatial dimensions of the car. Question also says assume that it's a cuboid. Okay. Now there is another column in the data frame which is curb weight. Okay, which is essentially the weight of the car in kilograms or pounds, whatever. That's also it's a series, it's a column in your data set. Question is saying calculate the density of each car and then store it as a new data frame. To calculate the density of each car and then store it as new data frame, what we have done, we have to first find the volume of each car. So volume of each car can be found using this command. Okay, df cars car length times df cars car width times df cars car height. Each of this is a series in your data frame. When you multiply, what will it do? It will do element wise multiplication. So for example here 168 into 64 into 48, that will be the first element in this series. Then next 168 into 64 into 48, again that will be the second element in the series. Next 171 into 65 into 52, that will be the third element in the series, and it will do this for all the rows. So the output of this, in fact I have calculated here, car wall. If I just say car wall equal to, and let me take df cars length into width into height. Okay, and I'll print this car wall. So 168 into 64 into 48, here is the value 528019. 168 64 48, again 528019. 171 65 52, 587 592, and so on. So element wise arithmetic operations can be done for n number of rows. Here I am showing 205. You can do this for 1000, 2000, 10,000 rows. As long as you know what the columns are. That's the point. As long as you understand the columns, feel free to do the operations. So this is now giving me the volume of each car. Okay. Now having the volume of each car as a series with the index matching with my data frame, then what I can do? I can get another column from my data frame which will have the same index, and I can continue doing my operations. So what is the other column in my data frame? Curb weight. So if you see, you just print this curb weight here, that also has the exact same indices. Why? Because it's from the same data frame. So now these two series have the exact same indices. Okay, and now I can do weight divided by this series here, car volume. what it's going to do is going to do 2548 divide by this value. Then next one 2548 divide by this value. Next 2823 divide by this value. And we know that the set of arithmetic operations that we are doing is basically finding density. So what you have done is essentially calculated density for each row in the data frame. Finally, you have this series. We can now put this series in a new column in the data frame, which is what we have done here. df cars bracket density. This thing density doesn't exist. If it did exist, it will overwrite. Be careful. That's the whole point. When you're changing your data frame, be careful. If there was a column called density, by mistake you will be overwriting it, right? So since this column doesn't exist, I'm more than happy to create it, and these are my density values with the exact same indices as the data frame. Okay, so now I can just assign this as a new column to my data frame. Again, note guys, the index that I'm talking about here, this is the LOC index. We are working with DF data frame. That is why you may be thinking 0, 1, 2, 3, 4 looks like integer. The index I'm working with is LOC. So later, please try this for tempdf. Go to tempdf and try some of these operations. The LOC indices need to match. Then only the operations will be done element wise. Okay. If the LOC indices do not match and what you're doing, the operations will go wrong. Okay. So what's happening here is the LOC indices are being matched. All right. Yeah. So hope that summarizes this. Yeah. Okay. So as I said, quiz 2 and quiz 4. Quiz 2, you know, I little bit of logic involved, little bit of GPT involved. Which command, Rajat? I have many commands here. In fact, I have used, you know, somebody's command here, Akash, I think. Yeah, here, let me just give Akash command. This is the one Akash used. The one I am using in step by step. Here it is. I'll show you. Where is it? This one. Yeah. So this is the set of commands. Yeah, step by step here. You need to copy paste and, you know, put it in separate lines. Okay. So this is the one that I have used step by step. You can investigate each object. That's good if that's what your interest is. Great. So yeah, quiz 2. Think about it a little. You know, it requires some math and logic. Quiz number 4 is a little bit more straightforward, I think. So you can try it yourself. We are going to move on with statistical operations. So we've seen some arithmetic operations, inter-series operations. Now we'll go to statistical operations. Okay. So again, I'm going with my DF data frame, and we have seen some of these methods before. Dot sum, dot mean. We have seen these methods. So suppose, for example, I do DF age. Everyone tell me? I have highlighted part of the code in my cell. Can you tell me what is this object? So DF age is series. Now we know that series has statistical operations like sum, mean, and all that. We saw that, right? So directly apply it. So now if I do DF age dot sum, and by the way, sum is not an attribute. Sum is a function, which is why we are putting the brackets. Okay. So if I do df age sum, what is it doing? It's giving me the summation of the age column, 318. Typically, can we say it as array? No, Pratim. I would like to call it a series. So the difference between array and series, I made it clear, right? Series is going to have these labels. Arrays only have integer index. So when you do data analysis, it's important to talk in terms of labels. Okay. So yeah, let's develop that, right? Which is why I have included that temp df in this workbook as well, right? Typically you will see that typically you will see, you know, some learning resources, they will use 0, 1, 2, 3 as the you know, the row indices. And I told you that what numpy index 0, 1, 2, 3 is already there. If you don't specify the pandas index, this thing comes forward. Okay. So some learning resources will use that. And my sense on the matter is that we should know both and we should understand what's happening. So if I call this an array, I'm basically saying it does not have a pandas index, but it does have a pandas index. This 0, 1, 2, 3, you're saying this is the pandas label, not the numpy label. The numpy, not even label, numpy integers. Numpy integer index is there behind. Okay. But pandas has made a copy of that. So now, you know, the temp df data frame, if you see, the indices are A1, A2, A3, A4. So in fact, you know, we can possibly even try with temp df. So temp df, now here, if I do temp df say age. Right now, everyone, can you tell me what is the output of this highlighted thing? I've written tempdf bracket age. And by the way, all series are array, but all array are not series. That makes sense, right? Yeah. So now if I do tempdf age, are you able to see 0, 1, 2, 3, or are you able to see A1, A2, A3? Which one? You are able to see A1, A2, A3, right? Yeah. So we should refer to this as Pandas series. Each column of a data frame is series. Each row of a data frame is also series. Okay. They are arrays in the backend, but Pandas provides you additional functionality. Okay. Anyway, so now if I want the mean of the age, I just take the series age. I can apply the mean method. So the mean age of the from room number A1 to A10 in my hotel is 31.8 years. So that's mean function. You can even find the mean expenditure. We've seen many of these methods before, right? So you can do df expenditure dot mean, and all of these are just series operations, right? So df expenditure dot mean, that's 17.69. That's the $69, by the way. So that's the mean expenditure of the people in the rooms in my hotel. Also, we have methods like max. So df age dot max gives me the max age in the age column. Df expenditure min gives me the minimum expenditure in my expenditure column. We also saw this idx min, idx max, right? So it gives me the index of the minimum age. So here it says 0. Let's go back to our data frame df. So minimum age is obviously 18, Shilpa, and the index is 0. Now, I think this method will make it very clear what index we are talking about, right? So here if I do tempdf age dot idx min, please notice the output. What is the output? A1, not 0. So this is my point. So when we are talking about pandas indices, we are talking about the non-numpy indices. We're talking about the labels. Okay, so you can see temp age dot idx min, it's not giving you 0, it is giving you A1. The only reason df is giving you 0 because we did not specify a pandas label for that row index. Okay, so to summarize that question, we should call these series only, and these labels are pandas labels. Okay, the numpy labels exist behind, they are there if you require. Okay, so if you saw, we spent way more time on LOC and not much time on iLoc. So yeah, so idx min gives you the index of the minimum value in the column. Idx max will give you the maximum, and I hope we all remember median. Median is like the middle value between between the one. You sort the series and then get the middle value, right? So of course we all remember the median formula. So you can find the median expenditure, that is 17.93. Mean expenditure was what? 17.69, right? So almost median is little higher, right? So all of these things, all of these methods exist. There is one very interesting method called uh, df.describe. Okay, this is very interesting, and it's typically used a lot. So if you remember in the last session, I said that df info, df columns, df index, and probably df shape or something else, these are important methods to study the structure of the data frame. df.describe is the best method to quickly study the numeric information in the dataset. So if I do df.describe, here I'll get age is numeric, expenditure is numeric, and it says count, mean, standard deviation, min, blah blah blah. So some of these other things you will study in more detail later in exploratory data analysis. I don't like this way of printing, so what I usually do is df describe and then transpose. Okay? So then it looks a little cleaner. So basically what it's telling you, median age is 28.5. See, 50% means median. So median age is 28.5. Median expenditure is 17.93, which you can confirm here somewhere. Yeah, median expenditure is 17.93. It gives you the mean also, 17.69. Here it's 17.69 mean expenditure. So df describe actually gives you all, and count means how many values are there. Okay, so this is very useful for numerical data, df.describe. Notice that it doesn't care about the other data, string, object. It will not even take it in the output. Obviously, what is the mean of name? There is no mean of name, right? For string data or categorical data like cuisine, it's Indian, American, whatever, there is a very interesting method called unique. So it will tell me the unique levels or unique values in that category. So df cuisine dot unique, if I do, it will show Indian, American, Chinese. Similar functions are available in Excel also. Microsoft Excel, whatever, you have similar functionality. So pandas essentially, takes that ahead further, and which is why we study this in detail. So dot unique gives you the unique values, right, in the categorical data. Now, if you also want how many Indian, how many American, how many whatever, right, then you can use this method called value counts. So if I do this, I'll get like this: Indian 5, American 3, Chinese 2. Okay. One thing to note is that keep checking the type of output. Okay. So df unique is giving me array, value counts is giving me series. Okay. But this series is a different series. This series is not having the indices same as the data frame. Okay. So here the index is Indian, American, Chinese, completely different series. Pratim, by using them, and don't worry, you will get there. Okay. As I said, now if you just scroll back up, and I'll scroll for a while because this is important. Please read this. You will work with all these methods throughout your data science learning journey and beyond. Does that answer your question, Pratim? I'm not expecting you to remember in one session at all. We will be using this again and again and again and again. Visualization, analysis, and a little bit of maybe stats, machine learning. Again and again we'll be using. Okay. So don't worry, nobody is expecting to memorize in one day. Not possible. Not possible. There are way too many methods. I agree. All right. So value counts is done. I think mean and median we spoke about. We know another statistical thing called mode, right? So mode usually it is applied to numerics. I think in school we were doing for numerical data, but typically speaking, you can apply to both. You can apply to categorical data like cuisine, Indian, American, whatever, or you can apply to numerical data also. No problem. This is max number of observations, correct. So if I do df cuisine mode, what is the answer? Indian. And I guess if you look at this, Indian is 5. Okay, so you can do this for numerics also. All right. Now there is a a generic method called aggregate. Okay. Now for example, if I just do df age dot mean. Okay. So what is the answer? 31.8. Correct. So what I've applied mean directly to age. There is a function called aggregate, which essentially what it's doing is all this mean, median, all these different aggregation functions, those will be parameters of these functions. So here if I say df age dot aggregate, now instead of using directly the function mean, I can specify the parameter as mean to this aggregate function. So if I do this, I'll get the same answer, 31.8. Now it seems useless right now. It's more important later. Okay. Reason is, for example, here, if I want to aggregate more than one column in terms of mean, right? Now first let's do, let's just do this subset. DF age expenditure. We all understand this. This is a subset of my data frame, right? It's also a data frame. My original DF had more columns. Now I just got the age and the expenditure column. Okay. Now suppose I want the mean age and the mean expenditure, and let me do dot mean here. Correct? This is what we would do. But if I do that, right, you will get 31.8 on age and 17.69 on expenditure. Now here, if you do aggregate on these two, you will get the exact same results. The only difference is that you can change what you are applying to each column. So I cannot apply median and mean separately here. So here together, if I want to apply mean, no problem. This aggregate function, what it helps me is, here for example, it's a dictionary. See the parameter, okay? It's a dictionary. So take the complete data frame dot aggregate, then put a dictionary inside, okay? And here take the column age and specify that, look, I want to aggregate by median take the column expenditure and say, look, I want to aggregate by mean. So now if I execute this, you will get slightly different from here. Can you see? This value is slightly different. So these two are exactly the same because you've been using mean for both columns. Here, directly do df dot aggregate, and here of course you can take subset also. Nobody is stopping. Okay, the subset of the data frame will still contain the age and the expenditure column, so no problem, right? So if I do this also, I will get the same output. Typically, you can also just call the original data frame, which also has the column age and expenditure. So again, no problem, right? You can do this, or you can take the subset and do also. And since the subset is already being done inside the dictionary, why should I subset outside? That's the point. So this allows me to get the aggregate separately for different columns. So here I have median age, and here I have mean expenditure. So these kinds of things will sort of be more useful when you do data analysis and things like that, because some features mean is a better representative, some features median is a better representative, some feature mode is a better representative, and so on, right? So you can choose which aggregation function you want to use. For example, price of car, maybe I want the mean, mileage I want the median, right? To see my data set what is the aggregate value. So that's where this aggregate function plays a role. Okay, to summarize, I think some of these are obvious, like sum, mean, median, all of that. IDX mean, IDX max, there was a little bit confusion between LOC, LOC. I hope that is clear. It is LOC. It is giving me the pandas index, right? IDX and all these things. And describe is something that we saw for numerics. Value counts is very useful for categorical variables, right? Like cuisine and things like that, which have fixed levels, Indian, whatever. Other type of categorical variable is what? Gender, male, female, right? Those kinds of things. So that's useful there. And aggregate is useful to pick and choose what kind of aggregation that you want for various features. All right. Are we ready for quiz? The first one. What is the price difference between the most and the least expensive car in the DF cars data frame? Let's try this quiz, quiz 5. How will I do this? Most and least expensive car. Of course, this is going to take a combination of commands. Step 1, find the row with the most expensive car. Step 2, find the row with the least expensive car. Okay, perfect. Let me check this. DF cars max, DF car price max minus the min. Yeah. So Ashish, I think this is the right answer. Really nice. DF cars price dot max. This will give me the maximum value in price. DF cars price dot min. This will give me the minimum value in DF cars price. Correct. Now I just need to subtract. So answer is $40,000. Okay. So just to make it clear, who is this DF cars price max? Let us see. I don't know who. So now, okay. Now how do I find out who this is? Which car this is? IDX max. Okay. So if I want to find out which cars this is, I have to first do IDX max. So here it's giving me the index, isn't it? Remember, is this the iLoc index or LOC index? Which one is it? Can everyone put in the chat? Is this the iLoc index that I'm getting here? What index I'm getting here? iLoc or LOC? iLoc. Oh, iLoc. I just showed you, no? Remember tempdf? So if I do tempdf age dot idx max. Sorry. What is this A8? A8 is iLoc or LOC? What is A8? LOC. So IDX max gives LOC. IDX min also gives LOC. Now why are you saying iLoc? LOC only. So df cars dot idx max is giving you the LOC index. So I can just do dot LOC, isn't it? I can just do df cars dot loc df cars price idx max. Yeah, loc, we all agree? It's loc. Okay, these methods are giving you the pandas labels. Loc. Yeah. So df cars price idx max 74, which is the loc index. Now I can do dot loc with that index and subset the data frame. So you will get the row. And why does the row look like this? Can someone tell me this is one row? Can someone tell me why does the row look like this? What is this? Dot loc. Yeah, it's a series. Exactly. It's a series. Even the row is also series. Okay. So pandas row is series, pandas column is series, right? And any combination of these is data frame. That's all. Okay. So here I just need the car name. So it's some Buick Regal Sport Coupe. I don't know what this is, but whatever. This is some car which has the highest price. You can see here 45,400. Okay. So you can see 45400, 45400. Okay. Is it clear? Confirmed? LOC. Okay. That's confirmed. Yeah. Great. Summarize DF using this main reading. You can do this later. I think you can do this later. Not a problem. I mean, it's similar to this, whatever I did here. So you can try this later. This is interesting. Can we try quiz number 7? Let's try quiz number 7. Are there more cars with 2 doors or 4 doors in the DF cars data frame? And note that the door number feature is actually a string. So one would expect the number of doors to be integer or something. But if you see the DF cars data frame, there is this thing called door number, but it has English values 2424. So what method can we use here? What do I need actually? I need to know, are there more cars with 2 door or 4 door? So I need the number of cars with 2 door and 4 doors. How to do that? I'll just scroll my screen to the hint. Here is the hint. Yeah, value count is a fast method to do that. Now of course you can do other method, right? You can do df bracket door number equal to what 2, and then df bracket equal to 4, subset, find the length. All that you can do, isn't it? We can do all that. But df cars, and then what is this thing called door number? If I just do door number and then I apply the value counts, just quickly gives me, right? 4 doors 115 cars, 2 doors 90 cars. Now the same thing if you want to do, of course you can do it using logical subsetting also, right? So you can definitely do something like this, right? df cars door number equal to 4, subset it, get the length 115. Okay. Similarly, same thing, df cars door number equal to 2, subset the data frame using the logical, get the length 90. So you can do this, but these methods are faster. Yeah, Pratham was trying that. Okay. The intention is to use the methods you recently saw. Okay. So here value counts directly gives you. Now imagine here door number we have 4 and 2. What if you had a categorical variable with so many levels, right? Suppose country, India, USA, France, China, and totally you have 10,000 rows or something. So it's probably more efficient to do dot value counts, right? Okay, so you can do dot value counts to answer this quiz. Yeah, please try. And I've shown you the logic method also. This is okay for this data set because it has only 2 levels. Okay, yeah, value counts is good here. All right. Yeah, this one is interesting. Okay, this one is very interesting. Let's do this. Use the mean function directly on the df movies data frame. Do this for both axes. First directly use it. Can everyone give me the command? So first let me print df movies. What is the command for applying the mean function directly on the data frame? Use your intuition at this point. Even if you have not seen it somewhere, what do you think the command looks like? Apply mean on the full data frame. Anyone? Yeah, df movies mean, correct. So I'm going to apply df movies dot mean. Now please execute this. So Akash, Ankita, you guys have given the correct code. Execute it. What is it doing? By default, it is executing for what? Columns or rows? What collapsed? Answer to me, what got collapsed? Rows or columns? Applies on the row or column. That's what you're saying. What got collapsed? Rows got collapsed. Correct. So axis equal to 0, isn't it? That's what happened here. Axis equal to 0. So if I just put that axis equal to 0, I will get the exact same result. Default is axis equal to 0. So if you do axis equal to 0 in this data frame, what are you getting? You are getting the mean rating for each movie. So Thor 6.5, Justice League 6.1, Spider-Man 6.65. Out of all these, now you can do something like .idx max to find out who is the most popular movie. Spider-Man. Okay. Make sense? That made sense, right? Now if I do axis equal to 1, suppose I do df movies dot mean axis equal to, what is going to collapse now? Columns will collapse, right? Look at the data frame. By default, row will collapse and you will get column wise mean. If I do axis equal to 1, columns will collapse. Columns will collapse, you will get row wise mean, right? Yeah. So here if I do axis equal to 1, look at the output. Columns have collapsed and now you're getting the row mean. What is this telling me? This is telling me which of these people actually like movies in general, basically, right? So I can, you understand, if I do axis equal to 0, it is telling me how good are the movies running. Okay. Like which movie is not doing well? Obviously something like Annabelle 5.4. It's not doing that well, right? Now if I do axis equal to 1, what is it giving me? It is saying which user likes movies in general. That is the answer that I'm getting from axis equal to 1. So here I can do something like .idx max, and for example Ravi really likes movies. So if you go see Ravi, his average rating for all the movies is 8.6, which means he's liking all the movies. Correct. Okay. So these are some, of course, remember axis wise operations and all these can also be applied. Fine. Okay. So we have a few, like about 20 minutes left. We'll go through some additional operations. Okay. So first thing is sorting, and as I said, sorting is very common operation. I think we saw something for series. We can see it for data frame also. So the way this works in data frame is there is a function called sort values. Okay, so this is an inbuilt function for the data frame, and there is a parameter called by. And I hope by now we are understanding, Python is a very English friendly language, as in human language friendly. So if you see the parameters and everything and the function names, all of them are representative of what it is doing. So you can actually read this in English. You can just directly use the words and read in English. Sort the values in my data frame by expenditure. Isn't it? That's all. Okay. So initially Python seems a bit weird, but slowly you'll see that it's quite, easy to use. So sort the values in my data frame by expenditure. Sure. What is this going to do? It's going to sort the whole rows using the expenditure sorting. So if I just do this, as you can see, this is ascending now. 11.09, 12.23, 12.56, 14.43. This is now ascending. So expenditure is going in ascending. Do you think that the other columns will not be disturbed? Of course they'll be disturbed. If you don't disturb the other columns, then you are losing your index. You are losing the information. So it is sorting all the observations according to one variable. Right? So that's what's happening here. Expenditure 11.9, 12.3. The rest of the information has to match with the same LOC. Okay. Now, just to make things really clear with this LOC business, can everyone tell me what is the LOC value for the first row that I'm highlighting here in this output data frame? Put it in the chat. What is the LOC index for this? Is what? No. Guys, see the index. Index is 6759. See, 6. 6. Do we agree it is 6? Is it a reading issue? Can't you see? Is it Zoom? 6, right? Yeah. So 6 is the LOC. Okay, wonderful. So what I'm going to do at this stage, I'm going to just save this in some variable called temp.df. Okay, I'll save this data frame. I will print it. Okay, you all agree that this is the exact data frame you just saw, correct? And the first row is 6, correct? Now if I do temp.df dot loc6, tell me the name of the person which I will get if I do dot loc6. Monica, correct? Wonderful. So if I do loc6, I will get Monica. Okay, very good. Now can you please tell me what is the iLoc for Monica in this data frame? iLoc, integer location. Room is a column, guys. Rajat, room is a column, not even an index right now. Room is a column. The index you are seeing is here. Okay, I'm getting 0 as the answer for iLoc. Yes. So if I do dot iLoc0, I will get Monica. I hope this makes the difference between LOC and iLoc very clear. iLoc is immutable integer index. LOC is our labeling. So if you see in temp.df here, temp.df, see the LOC, na? 6759, it makes no sense. 6579, that is not in order. So how you can think these are integer indexing? No, these are labels. 679, these are pandas labels, LOC. Okay, the iLoc are integers. So the iLoc for this data frame is different for the iLoc for the original. Why? Because the observations got mingled up. But the LOC remains the same, even if you mess up the observations. Wonderful. Same thing for columns, by the way, guys. Exact same thing for column also. Okay. Yeah. Because what is the difference between row and column? Nothing. This also series, this also series. Okay. Okay. Anyway, so continuing with sort values, if you don't want ascending, what you can do is you can put ascending equal to false, right? You can do that. And that will give you descending order, right? There's also a very interesting functionality where you can give list of two variables or features for the sort values method. What it will do is it will basically try to sort with cuisine first, and if two cuisine matches, then it will sort with expenditure. So it's a two-level sorting. Okay. So if I say df dot sort values by equal to cuisine expenditure, as you can see, American. So A because string sorting will be alphabetical, correct? So American, Chinese, Indian. Okay. So it has string sorted within the same American. It will sort the expenditure next. As you can see, it is sorting by expenditure 12.23, 18.54, 19.54. Okay. So you can do two-level sorting also. All right. Similarly, there is a function called sort index. So if I do df dot sort index, what's going to happen? Where is my df? Okay, nothing happened because my df is originally also 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are my labels. So if I sort index, nothing will happen because they are already sorted. Now if I do df sort index ascending equal to false, what will happen? See, my LOC indices have changed. My iLoc will not change. This output data frame, if I do iLoc 0, I will get Gaurav. Okay. If I do LOC 0, I will get Shilpa. All right. Great. So we'll quickly go through, some things here, some functions and some group by, and this might take maybe 5 minutes more. So I will need about 15 minutes from now. Is that okay with everyone? This is a little bit important part. Maybe we should, yeah, do that. Yeah. Okay. So functions. Now already I have showed you df.round, right? This is something I showed. Now I also told you that round will not affect things like room, name, cuisine. It will not affect because round is a mathematical function. Pandas knows which data type to apply, which to not apply. Okay. So if you do df.round, it will only round the numeric values. Now there is this very interesting thing called apply. Okay, there is this function called apply, which is a built-in method for DataFrame. What it does is it generalizes functions and then you can apply to the DataFrame. So basically what I've done here is I've taken numpy round. So I did not import numpy. Please import, guys, otherwise this won't work. So let me import numpy as np. Okay, and then np.round, which is a numpy function. Okay, so I can apply this numpy function on my data frame. So if I do df.apply round, now what is the problem? What's happening here? It is saying it cannot support argument on type string. Basically, inbuilt method, if you use df.round, this is a pandas inbuilt method. Inbuilt means that is why you are able to apply directly from data frame. But if you apply from other, like not an inbuilt function, np.round is not inbuilt into df in that sense, right? The name of the function is from numpy.round. This round has already been built into pandas with the name round. So if I try to apply np.round, you're going to get error here. Okay, so now how do you generalize? That is the question. So if you take expenditure and round, and why this is giving error? Because np.round does not know that it should not apply round on name, room, cuisine. NumPy doesn't know that. Only pandas knows that. So here, if I use dot round, this is pandas obviously. So this is a Pandas series and this is the built-in round method. It is rounding my expenditure. Okay. Now if I take that same expenditure series and I apply numpy round, it works. So when you're using an external function, not pandas, not inbuilt to the object, if you're using external function, it won't know. That function doesn't know whether you should apply to only one column, two column. That function doesn't. That you have to specify. Okay. So what's happening here is that this apply method allows for generalization. Okay. So if you are unhappy with the kind of functions that pandas have inbuilt, which is very unlikely because it has so many functions, but in case you need some general function, then you can define it and you can apply it. So for example, here I have df. Okay. And suppose, for whatever reason, I want to get the first three letters of everybody's name, right? Suppose that's my function, obtain the first three letters of everybody's name in the data frame. So what I can do is I can define a function called first three letters, and this is very basic string operation. Okay. So and by the way, these functions will apply to the full row. So that's why we should be careful that we are applying single column at a time. I will show you, what the issues are. So this, when you do the dot apply method, it considers whatever row available as your complete input. Okay. So that's why I'm calling it row here. And you can even call it X. If you don't like this, you can call it X. But yeah, you can just call it row because that's what it's applying on. So this is a simple string operation, right? So assuming that this row is a string, assuming that this row variable is a string, then string with indexing :3 will give me the first three letters 0, 1, 2, because string is nothing but it's a conjoined list of characters. So list accessing works on string. So let me define this function and it is returning the new. Okay, so row equal to row up to 3. So I will get the first three letters. Let me apply this. Okay. Now if I take df name dot apply, right, as you can see, I'm getting shi, js, dom, ahm. All of these are the first three letters of the names in my data frame. So what I've done is I've defined a function, assumed what should be my input. What is the input? It is the row of the object that you're applying. What is the object I'm applying here? Df name, which is a series. What is each row of the series? Only the full name. So if I do df name before this, these are my rows. These are my rows. Okay, so that's why I'm assuming that my row is a string, right? So then I'm applying this function on that and it is working. So you can do that for cuisine also, same function, so ind American, ind Chinese, whatever, right? Now what if you want to apply the function to two columns, name and cuisine both? So let's try it, right? Df, and this is the subset, isn't it? So if I just take this and print it, this is the subset. It has name and cuisine, Shilpa, Indian, Jasprit, whatever. Now if I apply this function and see the result, it will not make any sense. Why is this not making any sense? It's not making any sense because now this apply function doesn't know what row means, because here the row is essentially a subset of the series, isn't it? And a subset of a series is also series. So when you're doing the indexing method in this function here, you are actually doing some indexing with the series, but your intention was to split the string. Okay, so that's the one thing you need to keep in mind with apply, that it works better with single column. Apply works better with single column. Okay, if you really want to apply same function on 2-3 columns, you can use for loop or whatever, but there is one method called apply map. Okay, so this thing applies the function correctly to the 2 columns and it gives you the result of the application of 2 columns as a data frame. Okay, and finally, and by the way guys, don't worry, as I think one of you pointed out, so many methods cannot remember. Don't worry, just take your time and practice. Okay, anyway these methods will come again and again later. So I don't know if you all have studied any lambdas, right? We don't know. Can you just put in the chat if you know what a lambda function is? Oh, you know lambda. Great. Okay, then that's easy. So then this should be very obvious, right? So what is my df cuisine? Df cuisine is essentially Indian American, Indian American. So these are my rows, right? I am applying a lambda function. So what is the x in my lambda? It is this Indian American, Indian American, right? This is my lambda. X is all this. I am saying return the value 1 if x is Indian, else return 0. Okay, return 1 if x is Indian, else return 0. So if I apply this, wherever it is Indian, it will return 1. Wherever it is not Indian, it will return 0. Okay, it is applying on the each row of your item basically. Okay, I won't go into the quizzes right now because of time constraints. I would like to discuss group operations. This is quite important. Quizzes you can try on your own, right? More or less all these methods, I think we are getting better. Just try. And in fact, I think next week, as I said, there's a doubt resolution session. So definitely you can take up your doubts there. Okay. I want to use the rest of the time to discuss groups. And then there's a bit of work, additional work that you guys will do later. So this is one of the most interesting methods in Pandas and one of the most powerful methods in Pandas. Sonal, basically, I mean, see, the thing is that many of these things, it is expected that you guys need to do it. Okay, which is why I think Abhishek also pointed out there's a price pulse assignment. So slowly in the program, the expectation is that you start getting more familiar with these things and you start doing these things independently, right? As I said, ample support is there. If there are doubts and everything, we have doubt resolution session. Still, if the audience wants some kind of additional support, more than happy to discuss that and figure out, right? But the expectation is that learners also need to start putting effort from their side, right? So we will sort of enable you, right? We will enable you. We will tell you all this. Now, for example, if I ask the whole audience, are we comfortable with pandas to some extent? All of you will say, yes, I am comfortable. I know iLoc, I know column, I know pandas LOC, I know all of this. Yes, I'm somewhat comfortable. Can you try things on your own? Yes, I'm ready to try things on your own, right? So that's the expectation that we have from the learners also. Okay, having said that, if you guys are getting stuck somewhere and you need support, definitely there will be support. Okay, but the expectation is that you try it independently. Is that is fair, Sonal? Fair, na? Okay, right. So yeah, the last one thing that we want to discuss is group by, and after that I'll just discuss what the additional work is. So there's this function called group by in it's an inbuilt function to DataFrame. What it does is it creates a temporary object. So if I just do df group by and by equal to cuisine, you can see the output here. It says pandas core group by generic data frame group by object. Basically this data frame group by object. This is a temporary object. It has no output. Like as you can see, where is my data? Where is my expenditure? Where is all this? It's not there. So group by, what it's creating is it's creating groups. So when I say group by cuisine, what's happening is it's picking Indian and then creating a group of Indian, and then American, it's making group of American, and then Chinese, and then group of Chinese, right? And on the group by object, I can apply the mean function or any other type of function. And here I've written a parameter. Let me do without the parameter. So now if I group by cuisine and do mean, you will see that it says df group by mean is deprecated. In a future version, numeric only will go to default, whatever. These are just some updates. So here it is telling me, specify numeric only. Okay, then I'll just specify numeric only. These updates are very common. Okay, so if I do df group by and then apply mean, and then this parameter which Python itself told me that go ahead and apply it, as you can see here, it gives me the mean of the numeric variables for the groups. I hope that made sense. So from this, what I can see is that American mean age is 40. American mean expenditure is $16. So this is the American cuisine. So older people are preferring American cuisine and spending more money on it. Chinese 38.5, 12.76. So somewhat mid-age people are spending very less on Chinese. So we need to find out why the Chinese is not selling, for example, right? Or is it really cheap? And Indian young people are spending a lot of money on Indian cuisine. Okay, so this group by combined with statistical operations is one of the most powerful analytics methods in Pandas. Okay, so again, don't think that we are mastering group by and all this in this session. This will come up again and again in visualization, EDA, and all those. Okay, so I have applied mean here directly to the data frame, and it gave me some warning and all. So why don't I do something else? So for example, here if I say df group by cuisine, right, and this group by object, I will pull out the expenditure column. It says series group by now. Notice how Pandas is very clear in its output, right? Now it is saying that this is a series group by object. Why? Because I only took expenditure, which is now a series object. Now if I apply mean on the expenditure, I will get that. American people mean is 16.77 in the expenditure. Chinese is 12, right? So I'll get the mean expenditure for each of the groups. Now, even further, what you can do df group by cuisine, then expenditure. Okay, that's a series which is grouped series. Then I can apply external function such as np.mean. This also gives me the result. So group by plus apply, this combination can be used to achieve many things. So here what am I doing? For example, see here I'm doing df.group by cuisine and expenditure age. These two are numerics, right? These two are numerics. So the output of this is a data frame group by. Yeah, data frame group by. On that I am applying mean. Okay, very nice, right? And of course you can do the same using np mean, but here there will be some updates. Data frame mean, blah blah blah. What's it saying? To retain old behavior, use frame.mean access equal to 0. If you want to go through all this trouble of using np mean, we can do that, right? But ideally, I have a direct function called mean, so why would I do this? Okay, so there is always going to be some updates, but it is giving some answer, right? So why to use this method when I have this method? Finally, what I want to show is the combination of group by and aggregate. Okay, so here, for example, I'm doing df.group by cuisine. So this is a grouped data frame group object, which is grouped by cuisine. Then I can aggregate on this group by. So I'm using this aggregate function on group by, and I can aggregate. We all remember, right? Aggregate is where we had a dictionary and you can specify column value and you can say what you want to aggregate. So if I do this, right, it gives me the exact same result. American 16.7, Chinese 12.7, so on. But now if I want, and this one is obvious, right? Expenditure mean, age mean. So if I use aggregate on the grouped object with expenditure mean, age mean, I'll get mean of expenditure and mean of age for American, Chinese, Indian. But suppose you want different aggregation method, right? So expenditure, suppose I want median, and age I want mean. So maybe I want to change this to mean, suppose, right? So I have expenditure median, age mean. So what I'm doing is grouping by cuisine and then putting aggregate function on it. Expenditure I want median aggregate, age I want mean aggregate, print it. And now it will give me the mean ages of these groups, cuisine groups, and the median expenditure of these groups. Okay. So, you know, I typically in data analysis, you might want to find the total expenditure. So if just think you are the hotel manager and what do you want to know the mean age group, mean age. What is the mean age of the people who are preferring American food? What is the mean age of the people who are preferring Chinese food? What is the mean age of the people who are preferring Indian food? That is one thing you want to know. Another thing you want to know is what is the sum of the money spent on American cuisine by the people in the hotel. What is the sum of the expenditure spent on Chinese, right? So on aggregate, you can now use expenditure sum, age, mean, group by cuisine. You do that, and this is what you get, right? You have the mean age of the people preferring American, Chinese, Indian here, and you have the total amount of money spent on these cuisines here. Okay. So just to summarize, right? We have spent a lot of time familiarizing ourselves with the behavior of pandas. We've done the fundamentals in great detail. Okay, I have introduced you to some methods which you should start exploring and try to work it on your own, right? There are ample practice questions, so once you finish NumPy and all of that, you can do the pandas practice also. And please note that, again, I need to repeat myself, we are not mastering these techniques in one session. These are techniques that we will need and we will use in further topics also. Okay, so there are a few quizzes here. You can try them on your own. And so again, these are all using group by, using apply. Try to use the different methods. Okay, try to use whatever methods you feel comfortable, but try to use the different methods. Okay. And here in other data frame operations, here I've kept some operations which maybe you will not use too much, which is why I kept it at the end. So you have things like deleting elements from data frames, changing elements in data frames. When I say changing elements, I mean changing one by one, right? So some of these methods, I have given some examples here. You can try it on your own. These will be done in more detail when you do data pre-processing and things like that. Okay, so it doesn't make too much sense to study all of this in pandas, because anyway we will be using these methods when you do data pre-processing, exploratory data analysis, things like that. Okay, so adding new rows, columns, all of that. And finally, inter data frame operations, I just kept a very short bit here, and as you can see, I'm just showing two methods, join and merge. No need to worry too much about this right now, because it will become more important, as I said, in data pre-processing. The reason I've left it here is so that you guys can start exploring these things, and when we go to visualization, pre-processing and all that, we know, okay, we have seen these methods before, let us see it in more detail. All right, so just want to summarize this, that the whole section, right? We started with NumPy. We understood NumPy arrays, we understood indexing, the data types that are stored. Then we understood that pandas is built on NumPy, and Pandas series is a very, improved version of array. It can store data of multiple type, and it has labeled indices. And now you can take these Pandas series and put them together to create what we call a data frame. And data frames are typically the most common type of data structure used to read, analyze, manipulate tabular data. And we have seen multiple tabular data in these sessions: car data, movies data, buffet data, so all those kinds of things. So of course we'll be seeing many different data now as we go into the next topics, visualization, all of that. We'll be seeing way different type of data. And the way you need to think about all of this is that fundamentals, we have spent more time, and applications, we have done introductory, And these applications we will be using again and again in the future topics. And second point, yes, effort from the learner side is definitely expected. You guys need to try out all these things. So we will sort of enable you to some extent that, okay, are you comfortable enough with these tools? Are you comfortable with these concepts, right? And then the learners are expected, okay, go and do some additional things on your own. Okay, so that provides for the best sort of learning experience, is what I feel.
Well done. You have completed this Pandas tutorial and taken a big step towards mastering data handling and analysis in Python. From creating series and data frames to performing advanced operations, you now have the tools to handle real-world data analysis tasks confidently. If you want to further continue your data science journey, I recommend that you watch my video on Matplotlib and Seaborn by clicking on the info card above. The resources for this tutorial, including code files and datasets, are linked in the description below. Don't forget to check them out. Got questions or suggestions? Please share them in the comments. I'd love to hear from you. Don't forget to like this video, subscribe to the channel, and click the bell icon to stay updated with our latest data science tutorials. Thank you for watching and happy coding.